morning, good afternoon, good evening, wherever you are in the world, and welcome to Bitcoin Association's DevCon Day 2. We've almost hit an important milestone with 950 registrations, so almost 1,000 people joining us. So yesterday, the focus was quite intensely on the theoretical side, and today we're moving more towards the practical. But we have quite a wide audience at this particular event, and interestingly, it's a fairly even mix between people who appear to be relatively new to Bitcoin SV, as well as some of the old stalwarts who've been around for quite some time. So I think some of that theoretical stuff was probably quite important for some of the newer people. And that's not to say that the practical isn't going to be. Today, I think we've got an exciting lineup because this is the part where we get into the meaty bits, where we show you some of the things that will actually let you start working with Bitcoin SV right away. So some of the things we're going to be seeing today: the Handcash Connect API, a demonstration of Run on Bitcoin, which is kind of a token platform. I'll let Brenton Gunning explain exactly what it is to you. Scrypt, the high-level language IDE for writing Bitcoin scripts. And we have an appearance from Planaria Corp. Glenn Wolfe will be representing Planaria today to show off some of Unwriter and Planaria's tools. And finally, we'll have a panel with a few other luminaries from the Bitcoin SV platform development space. The focus here is on platforms, which are tools that you as developers can use to start building your own applications. But Bitcoin is a system that combines economics with technology, and in building an application, that means that there are more considerations than usual in application development. Joshua Hensley is going to kick us off today. He's a well-known advocate for business sensible application design in the Bitcoin space, and also very familiar with a lot of the tools. So along with his thoughts on how to combine technology with sensible economics, an overview of some of the things, some of the tools that you can use before we deep dive into a few of them. So I would like to welcome Josh Hensley.
Thanks, Steve, for that introduction. All right, good morning, everyone, or good afternoon, wherever you are. So I'm going to start my presentation here. Share my screen. Okay, so as Steve mentioned, I'm going to be talking about business sensibilities when developing onto Bitcoin SV. So also, please ask questions and we will address those at the end of the presentation. I think this one will be relatively short, so we should be able to get to the Q&A. All right, so I'll go ahead and get started here. So the objectives of it is to talk about the approach for starting a Bitcoin business, talk about the importance of revenue generation from day one because of its ease. This notion of co-opetition, meaning how we all have our incentives aligned, but obviously as a business, you want more Bitcoins than the other business, or you want to generate more than your competitors. Yet you are kind of working together since we're all in the same ledger. How micropayments enables the new internet. Lots of things were added to the internet because micropayments weren't. And I'm going to talk about how we can change our mentality with that in mind. And then do's and don'ts when operating in the Bitcoin space. All right, so I mentioned this some time ago, 3 months ago. Bitcoin app should be generating revenue in the alpha. And this is not to imply that you guys should be profitable, or even myself should be profitable because of how small and early we all still are, but because of how easy it is to do it in your application with the different tools like Money Button and just the simple power of Bitcoin outputs. So it's so trivial to pay yourselves in the output. It's no reason not to do it. So you can advertise and signal on chain by using what's been popular lately with vanity addresses. So whether that's in your Bitcoin protocol that's your prefix for all your transactions on chain, or whether that's where you receive them. I mean, there's privacy issues there, but there's uses for it as well. So like, I know Baymail uses one, Twitch uses one, different apps are starting to use these. And it's like advertising. So when people go to the Block Explorer, they see, oh, this one's done X amount of transactions, and they look, and there's the name of the app. Also, when you start paying people in different outputs, you keep your employees motivated. Like imagine open up your wallet and you just see payments constantly throughout the day. That would, okay, I get 1,000 Satoshis here, 10,000 there, 100,000 there. I think, I know personally for me, that makes me want to earn more ASAP. Okay, this was a relatively new service. It's called Dimely, and the tagline is, your time is worth a dime. We've all heard the saying that time is money. Well, we should treat it as so. Dimely is still immature, but I think that we should see more businesses using this. So if we're building on Bitcoin, we should be using Bitcoin, right? So I know one thing, I see this in the Slack chats and Telegrams where people are asking questions and this stuff is valuable, right? Well, I think a lot of people would like to call different individuals based off their particular set of knowledge and maybe pay for that. I think that's valuable. And then that would also give that person a way to generate income stream for themselves. So, imagine some of these businesses where the guy puts himself out there for an hour and, maybe the rate is $1 or 50 cents a minute. And now he's actually opening himself up to maybe the people that are using his service, or he just, is, giving out knowledge that can help other people build on top of Bitcoin. So I think this is important. I know it had a boom and it's kind of less users over the last few months, but I would like to see this come back and be used, because I think it has applications. And especially since we're so niche, right? That a lot of knowledge is in different people's minds, but not necessarily out there in the public. And, if people make themselves available, I think there would be demand for their knowledge and they would be willing to pay for it. Okay, this features app, this has been a recent trend. So different sites have added these features pages where they allow crowdfunding on chain of different things that they could add to their site. So for example, here, Twitch has direct messages, video calls, and this is a good way to communicate the roadmap without disclosing the necessary direction, right? Because lots of folks want to keep the roadmap private for obvious reasons, but it's open, yet there's no, the penalty for revealing what you would work on is that you get money. So this makes sense to do and you could release a subset of features, right? And you could just let people kind of vote with their Bitcoins, what they want to see from you. And then you'd be held accountable to deliver this. So if, one of these gets funded, if it sits there for a long amount of time and the funds start moving, you could see that on chain, people would start asking questions, say, hey, what are these guys doing? Did they just exit scam? So I think this is a great way to show your users what you're willing to work on, but also show what you're not willing to work on. So you could price a feature absurdly high to say, hey, I'll do this even though I don't want to, but the price is going to be higher. And it also sets expectations with your customers about what you're working on. So that the users can know what to expect, what's coming, and they can also understand why something hasn't been delivered. So, if everyone's asking for a same feature, well, they can just come here and say, oh, okay, well, it needs 9 more Bitcoins to fund, and maybe I should contribute to that. And then they could also feel like they're a part of the decision-making process, where they're not being dictated what the company thinks is valuable, but where they're kind of collaborating with everyone, including the business owners, about what they want to see added to an app that they use. All right, collaboration. I think this is kind of a theme of this presentation. So I think that because we're all building on the same ledger, that integrating with as many services as possible is so important, because lots of other people have built things that we can use. And it's better to do that, obviously, than it is to kind of make your own thing. You don't want to be working on low-level stuff when other people have already built something that you can use. It also makes you keep the line of communication open with other businesses. So that way no double work isn't being done. So if you're working on something that you know you need for your app, it would make sense to check what's out there first and talk to others so you can also get a gist of what they're working on. So you know, excuse me, not to duplicate, and you know not to like reinvent the wheel, so to speak. And you can also learn from them about what can potentially be done, what can be added, and maybe even some inside information on what's going on between different businesses. You also give the users opportunities to use these different tools and apps. So if like with RelayX here, they display all these different Bitcoin businesses inside their wallet. So like users can easily access them, which we all want, right? We want users trying out these different apps because we want more transactions. We want more diverse ecosystem. I mentioned about learn what works, what doesn't. So, you know, maybe if you reach out to someone saying, hey, I got this tool, or you guys have this tool that I'd like to use, and they could give info, hey, you know, you should use this versus that, and this works, that doesn't. All right, co-opetition. So I mentioned this, I talked about the features, how Donnelly launched that first, and you had 4 other businesses follow suit quickly because it was a good idea. Now, is that copying, right? Copying in this case was quite effective, and it is competitive, yet it is cooperative, right? Because Baymail doesn't necessarily compete with Streamanity, yet they copied from a different business, but that works out to their advantage. And then you can see Jack Lew kind of taunting the Volt guys, who also have a pretty sweet wallet, saying that they're also going to add this in-app browser, which is great, right? I mean, that will just let people decide, okay, is Volt better? Is RelayX better? You know, it's out there for everyone to decide kind of which wallet they want to use. So I think it's great for others to kind of implement what others have built, because that shows what's working in the market. And you could do it better, right? You might see what someone else did and you say, hey, not only can I copy this, but I can actually do it better. And I can bring more users and get more Bitcoins because of my unique application. All right, TonicPow. So TonicPow, I'm glad that they have, they've been more vocal on social media lately, and we've seen lots of offers out there. So if you're a business, you should definitely be creating offers and funding them with, you know, it could be a small amount of Bitcoin. And then that way you get users sharing this stuff. And if you're not aware of TonicPow, it's I think the primary use case for it right now is being able to fund offers with Bitcoin, and then when the people who share it, they get paid out every time someone clicks the link. So I know me, I'm constantly checking the offers page for stuff that I can share out on social media, and I've earned a decent amount of Bitcoin from doing this. But not only did I earn some Bitcoin, but it also spreads this app or whatever this is throughout all the other people that hold Bitcoin. Because, you know, a lot of us are following each other out there on social media. So we see this stuff, we click on it, and we see, oh, new app, maybe I should go try that. So I think we have an incentive to use something like this. And I think any business should be putting their offers out there. This was a few months ago, but Ryan Charles and the creator of Peer Game, Jeff Pike, sorry if I mispronounced that, but they did a great interview talking about some of this. And Jeff suggested that if you're still on Twitter, you should follow as many BSV accounts as possible. And they're easy to identify because they all have their Handcash handles and their shilling for tips and stuff, or their money button paymail. So they're pretty easy to find. So if you're a business, you should follow as many as possible. They'll follow you back, and you kind of grow this network higher and outwards so that you could reach as many people as possible. All right, so now I'm going to transition a bit and talk about how micropayments enables the new internet. So this is sort of a controversial twitch, but I think it's a bold one. But it's the entire pre-BSV stack is obsolete. So I'm not sure I necessarily agree with what's stated here, but I do believe that micropayments make a lot of the stuff added to the internet obsolete. So that's what I'm going to get into in the next few slides. So everyone knows this quote from Ryan, use every problem with Bitcoin can be solved with Bitcoin. So I think when it comes to implementing these old protocols, let me go ahead and get into those. So like HTTPS, DNS, SFTP, OAuth, a lot of this stuff is added because the internet is inherently insecure. But some of these solutions, depending on what you're doing, are not needed when it comes to building out your business. So I'll just say this straight up. I hate seeing something like OAuth implemented when we have much more secure and sensible ways of logging into an app. OAuth is something that's a terrible user experience, but I get why it was made, right? Because it was made in the absence of Bitcoin. But when we have Bitcoin, if I have a wallet and I can just sign a message and just demonstrate, okay, I'm the owner of these keys or whatever, that's all I need to do, right? Then the micropayments and security. I know Craig has talked about this a lot. If you have a wallet, maybe you have a hot wallet sitting there with $4 that's running a bot, do you necessarily need to secure that with a crazy amount with, you know, with what people do today? Probably not, right? Because it's not even worth the $4 that's in the wallet. If it's going to cost me $100 to secure $4, that's nonsensical. I would rather lose the $4 and not even probably triage the problem because it's just $4. I would spend more time figuring out who hacked and stole my $4 than what the hacker stole. If even a hacker decides it's worth it, which it's not. So I think we guys, with micropayments and the ability to hold small amounts to do different tasks, we really got to rethink security and why these protocols were created. And, you know, I know like with SFTP, I've implemented that in my past job. And it's just terrible. It's just too much. Like you have to, like they're paying consultants all these hundreds of dollars to implement this stuff. It's like, well, you know, in the new world, do we need that anymore? If this cost of, if the risk is lower, then the cost of security becomes lower. Also, when you're using micropayments, we don't need lots of info. I'm going to get into this because this is one of my favorite quotes in the white paper. It talks about how the companies have to harass their customers for more info because they're not giving the money straight out. And if they do want money via credit cards, they have to ask for basically everything that the user's ever done. They need address, they need shipping address, they need name, they need phone number, email. It's just crazy. So I'll jump, I know I'm jumping around here a bit, but I'll come back to that point about the collecting information. But harping on the login thing. So back a couple years ago when Streamanity implemented, they abandoned the Cashport login and they implemented Google and Twitter. They were heavily criticized by Bitcoin users by that because lots of people are anti-Google and Twitter and they would rather log in with their Bitcoin wallet because Streamanity shouldn't care who the user is if they're getting money from them. So I just, you know, I talk about OAuth, I talk about this other stuff, email, username, passwords, all that's worse than just signing some challenge message from the platform, whatever Bitcoin wallet they have, because it doesn't matter because they all use private key, private public key, ECDSA. So there's no need to implement different weird login systems when all users have the same wallet, essentially. Even if whether it's Handcash, whether it's Money Button, whether it's SendMe, doesn't matter. So I think Streamanity made a mistake here, and I hope people can learn from it. Okay, so this kind of goes into captchas. So captchas are also another thing that was created because the internet is insecure. They basically want people to prove that they're not a bot. It's super annoying. People hate this. You can see this funny meme here. So shout out to Chris Meza Kappa. I think I'm saying his last name right, for that awesome Craig meme. But no one wants to click that crap, right? Like if Money Button is a great solution for logins. Like if I'm just swiping, that is a captcha, right? And that can optionally be a Bitcoin payment. So there's no reason to implement this other stuff. Like I don't need to prove my email ownership over an email address and a password if I'm just gonna give you money. Like that's because the whole point was just make sure that you're not a bot. Bots don't have any money, so they're not gonna give you any money. So I just want to emphasize here, I think Bitcoin kind of deprecates captcha. Money Button's a captcha. And a Bitcoin transaction or signing of a message, that's a captcha. Proof of work is also a captcha. This is also in the white paper. And it's one of the reasons that it's implemented is that you need to demonstrate some type of effort in order to prove something. That you can't, proof of a email address is nothing. I mean, we saw that recent Twitter hack. So I really think hopefully this can kind of shift the thinking that's been happening with the old internet paradigm. Bitcoin is just greater than the internet. I'm not saying that it's going to replace it, but I think there's just a lot of things. We don't need those stopgap solutions created in its absence. So I'm highlighting that quote here. With the possibility of reversal, need for trust spreads, reversal of payments. Merchants must be wary of their customers hassling them for more info than they would otherwise need, right? And I think when we lower that and we also reduce our risk, right? If I don't even have to collect your email address and store it in a database, my business has less of a cost because I don't have all this customer info stored. So it's that cost for securing goes away, the cost of storage goes away, thus my revenue my profit margin rises as a result. So we shouldn't bring that stuff into our Bitcoin business because it's handled by the network. Micropayments just completely obsolete this stuff. So we saw this recent Twitter hack where they've got all this data sitting on their servers, and the issue with Twitter is there's no micropayments. That's why they got to do all these ads, and all these social media influencers get lots of followers and they make money from it because people go to their pages, people follow them, and they see all these ads. But when people are paying you 2 cents per interactions, you don't need to know your customer, right? Like, I don't need to know who you are. Like, why would I grill someone for any type of information if you're giving me money every time you use the site? Like Twitch or Streamani is a great example of this. Like, they don't need to know anything. They just need to know that you got money and you want to pay them. As long as you're not doing anything illegal. I mean, I think that's the key here. All right, so to sum up, dudes, I know I focused on kind of the internet stuff, but I think that's important because I really do think that building a business, you don't want to spend, I think spending, if you were to start an internet company maybe 3 years ago, I think that this is kind of a mentality shift because if you look up, okay, I need to implement a login system. I need to store XYZ in a database. I need to secure this. I think a lot of those costs, just 95% of that goes away. Not saying that you need to store it on chain or anything like that, but I just think there's not a need for it because if you are taking micropayments or if you're taking any type of payment, it drastically lowers all of that. So I just want to get into do's and don'ts here. So do leverage tools that others have built. So meaning don't re-roll your own stuff. Do charge for your time. I think I do want to see more of this. I think this is something I'm going to do myself because I think lots of information is just sitting in people's brains and we want a way to extract that out. And I think making yourself available and being incentivized to do so by being able to simply take payments for a phone call is a great thing. Do fundraise on chain because like I said, I think that holds you accountable as a business, but also has a clear communication with what you're willing to work on. And do pay your employees out and outputs. This is something I would love to see more. I think it's continuous motivation. I know that I've noticed this over the past year or so, is that every so often I'll just get addicted to trying to get more Satoshis. I don't know, I can't really explain it, but whether that's TonicPow, posting on any of the social media sites, shilling, Streamani links, whatever it is. I just want to humans are greedy, right? We want more money and we love seeing number go up, which I think the more important one is Satoshi's in your wallet. And then don't. So some of these might be controversial. Do not build your own wallet. So I'm not saying don't build a wallet. I'm saying if you're running an app that does, if you're running like a blog site, I don't think you should build your own wallet. I think wallets should allow their users to just seamlessly log in with the PKI that's provided to us by the ledger. And that's it. Like, if you build your own wallet, that's not time you're spending on building your app that people want to use. Because if you build your own wallet, no one's going to use that wallet. They're going to use Money Button or Handcash, right? They're not No one's going to use your in-app wallet that is only for your app. I mean, yes, it could be used for other ones, but my point is it just makes more sense to work with the wallet providers to just normalize the login versus rolling your own thing. Do not run a full node. I don't know how many times this has to be said, but it's getting even more and more crazy, especially with these stress tests. We still have stuff going down. No need to run it. There's so many tools out there. Unwriter's got, there's different APIs. It's just, I know Zokin just came out with something this morning. There's just no need to run your own node. Here's something else, not taking functionality away. So I talked about that example with the Google and Twitter logins for Streamanity. In that case, they took away a Bitcoin login. I know there was some stuff there with Handcash and Cashport, but it's not a good signal to your user when you take something away. If you put in something, don't remove it later, especially if it's widely used, right? Because you're going to do nothing but alienate your customer base. And then my last point, do not implement legacy login systems. I've seen comments from people out there on social media that they don't even want to enter a username and password because of how bad the hacks have gotten. I mean, it's just so crazy out there with, people just holding. I mean, email addresses are valuable. We know that because of how many spam emails we get. Businesses do not want to hold on to this stuff, but they have to today because they feel like this is the only way. And my assertion is that it's different now. And I really think that, I think it should be as simple as signing, pressing a message to like produce a signature from your wallet, the back end of the app validating that, and then letting you in because you're about to give them money. And that's really what it's about. All right, I mentioned before that the internet's a mesh. It's something Craig's talked about. I think that the more we think about the small world network, it's not just the ledger. I think it's the people associated with it. And we think about that when it comes to running our business, how we want to connect with each other, how we want to cooperate and compete with each other, and also share ideas, keep the line of communication, be friends, all that sort of stuff. I really think it really is a small world. All right, so that's it for my presentation. And now I'd like to take the questions. Should I stop sharing?
Yeah. There's so anyone, the questions are currently open. Josh, you've been through a few of the tools. I'm actually kind of interested to know if you were building an app today. Is any particular kind of set that you would pick? I mean, fundamental functions, I think you identified a few there. So you need to be able to interact with keys. You need to be able to create transactions. Could you maybe, without picking any favorites here, give us an example of a tool chain that would allow you to handle the whole flow of being able to create a transaction, get it onto chain?
Yeah. So I think the obvious choice for logging in at the moment and broadcasting transactions is MoneyButton. I do think while MoneyButton has implemented OAuth, that there's a better way to be able to log in because it supports the crypto operations API, which just allows you to sign and encrypt and decrypt. So I think I think Unwriter has already implemented that kind of with the PowPing. Like there's no OAuth there. I think you just sign and then you're in. And then as far as fetching data from the chain, I found BitBus to be quite useful. So there's two different endpoints to get confirmed and unconfirmed transactions. The only nuance there is that you have to do some matching between to make sure there's no duplicates. The unconfirmed set is kept over a rolling 24 hours. But you can query those APIs with your same query, and then you can get everything you need, and the APIs are quite fast. And now you have all the data that you need to display to your user.
So you mentioned the PowPing onboarding experience with MoneyButton. This is more a question about MoneyButton than it is about PowPing. For me, that was simple because I already had a MoneyButton account. Now, bearing in mind that a PowPing user might be someone who actually doesn't even have a Bitcoin SV wallet, how do you think MoneyButton could improve that sort of that flow for the user to simplify it? And do you think they should?
To simplify the login?
Well, for the new user that doesn't have a Money Button account, you go to Powping and all of a sudden you're on this other site called Money Button. What's this Money Button? Why am I making an account?
Yeah. Well, I think I'm not sure if that's a because even if the user signs up for the Money Button, that's still kind of a hurdle, right? I mean, to your point, I think that's more of like Powping. I think, yeah, I mean, at the minute, Money Button's convenient, but I think overall, I foresee where we need to support different wallets, but the different wallets kind of standardize how you log in versus addressing that problem directly, if that makes sense.
Certainly. All right, well, we've had a flood of questions that have just come in, and I think you should be able to see them on your screen now. So first one from Kevin, do you think that Steve Jobs and the next platform or the next machine influence some of the projects happening right now?
So I'm not familiar with Next, but I definitely think Steve Jobs had a huge influence. I know we see that with Handcash, how they really seek to make Bitcoin wallet for just anyone. And it really looks smooth, kind of more like the typical financial apps that we have.
Yeah. So Next was a computing platform. I'm not sure if it referred to the machine itself or the operating system that was running on top of it, but it was a miserable failure. In fact, it was. I think some people speculated it almost sent Apple under, but just for the background, that's what it is. I actually am a great believer that failure can make it the man or woman or person. I've had a few failures in my life that drove me to the next project that actually worked. So we have an anon question here, which touches on the subject of logins. Can a legacy login not also be used to get people into a Bitcoin login? I suspect what he's talking about, or what they're talking about here, is as a gateway, I suppose, for people who are more familiar with non-Bitcoin style experiences.
I mean, I think maybe now, yeah, but like if I sign up for a wallet, like for example, Simply Cash or Relay, I don't have to give any info. I just download and I can immediately start using it. I don't get prompted with that silly screen about signing with Google, Twitter, Facebook, blah, 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 blah. I download it and I can use it. So I think people want that. I think any type of hurdle, I think there's lots of stats out there about the more barriers to entry, the less likely a user is going to use your app. So I think we should just go ahead and remove that. Because I mean, if they're going to log in to a Bitcoin app and pay, they need Bitcoin. I mean, that's something that's just got to happen. So I've been thinking about this issue for a long time, and I think we should just move away from it. That's my view.
Sure. Another question on the subject of logins. Do you think that OAuth login with traditional services should be used purely as a way of building an identity? Example, a login with Bitcoin, prove identity with Twitter. Is there a role for off-chain identity in establishing a Bitcoin-based identity?
Perhaps now as a way of onboarding new people. I do think in the future, I mean, identity has become sort of a coming soon meme on SV, but I really think identity is one of the major use cases. And I know Craig has talked about how it's firewall, which basically means that the service doesn't need to know all this stuff. They only need to know certain parts about you. So as you build sort of a reputation against a set of keys on chain, and this is not to say that code is law or anything like that, or that private key represents an identity. But obviously, if there's a pay mail that's linked to a pub key, and you see that pub key, okay, they've sent 50 bay mails, they've posted 80 twitches, they've funded, I don't know how many things on Streamanity, they've been into they post on Powping a lot. Obviously, that is a reputation, right? So I think validating something like that, where you can see provably that they've interacted with these different services and spent lots of money, that is more powerful than just validating some email address or some ownership of a Twitter account, which we know is problematic, right? Because of all the bots.
Certainly. So I'm having a technical difficulty here. I meant to highlight a question and I accidentally archived it. John Pitts is asking, what do you think is the most differentiating feature of using Planaria's suite of tools, and then again runs tools? Can you also talk about a limitation that each one has?
So I'll address the limitations first. For anything Planaria, the limitation is, I don't think it's fully worked out how to deal with when there's lots of volume on the network. So that's an issue. So if you are, as soon as there's 1 million transactions on chain that are unconfirmed, you might have performance problems. Run also has the same limitation because of having to go back. I do think that can be solved at some point, but if you have a jig that you've updated 100 times, it always needs to validate the history. There needs to be stuff in place where you only have to check a certain amount back instead of checking the full chain. So those limitations of both, and differentiating feature of the Planaria set is the concept of serverless, I think. So I know I've used Bitbus to just be able to get whatever I'm interested in. It's a simple API call, which every dev knows how to do. And then you can use it from any language. So I think that's pretty nice. And then Run is establishing, even though it's not public yet, it is established. It's already used in lots of apps, but it's already establishing this idea of an NFT, non-fungible token, or an object on chain, which I think is probably going to be the most powerful use case that we'll see in the short term. Is as we start seeing, game items and that sort of stuff, we know that's getting popular in the mainstream. And the idea of having that on a single chain that's referenceable and open to everybody, I think the uses for that are pretty unlimited.
So why is it powerful to have it on a single chain? Is this an interoperability thing?
That, and the fact that everyone can see it and use it and not have to ask you. Like, I know in my past integration work, you're talking about weeks or days to congregate and talk with the vendors and scheduling the time. And then that's the other thing, is it's only 9 to 5 in that world, right? But now all these people all over the world are working on this. If you just see, okay, they're adhering to the Run protocol, I look at the chain, you can even look it up on your own as long as you have the hash. When you talk about that barrier to entry coming through the floor, now you just let people off to the races and start coding, versus having to congregate and coordinate meetings and understand the spec. You can just look at it.
On the Run thing, you mentioned the issue of having to validate kind of long chains of history. This is a well-known problem in token space, which is generally solved with some kind of a checkpointing system. In Bitcoin, we call those checkpoints blocks, but in second layer tokens, there's always kind of some other mechanism. Often it just means go back to the issuer and have to reissue the asset. But it's an interesting, I say, problem to understand, because it's one of those very, very engineering style trade-offs where the solution in one situation could actually be a problem in another situation, and vice versa. So we've got another question here from Konstantinos about paying employees in outputs. Do they get paid 100% in outputs without a base salary? What is the current practice across Bitcoin startups?
So I don't know the financials of the different businesses that do it, but I do think, based off what I've heard, that this does happen. As far as the base part, that may exist, that may not. I think we are too early. I'm kind of jumping the gun about it, but I do think I wanted to talk more about the positive aspects of it, because like I said, if you get notifications that are basically saying you got paid every so often, I mean, everyone knows the meme about I just got paid, it's Friday, we're going out, right? But that makes people happy when they see that ledger entry on their bank account. But now you can get that, hundreds of times a day. I just think that kind of flips the script, and that kind of keeps people motivated to working. And it also, base salary, I think that kind of implies that you're working fixed amount of time. With this Corona thing, we're already seeing the impacts of, okay, now everyone's at home. What does that change? Does a base salary make sense anymore when you can work 7 days a week during any time slot versus previously the Monday 9 to 5 or whatever? So, we're still early, but I do think that once the company does have some revenue, I think this outputs thing will be pretty interesting to see.
Sure. I have in the past at various times either taken all of or some of my my own pay in Bitcoin, and being on a monthly cycle, it was a common experience as payday kind of arose, came close. I'd be sitting there watching the markets going, oh, is it going to go up? Is it going to go down? And when it went down, I was like, oh, I hope they pay early this month. And if it went up, and that meant that there were some months where I was over the moon because I got paid just after the price had a big spike, and others when I was quite unhappy because it just dipped. And one thing I certainly wanted or would have craved would be, at the very least, to just be able to take it kind of on a daily basis to smooth things out. Yeah.
And the low fees make that possible.
Yeah, certainly. So I have we've got time just for one more question. Kevin, I'm sorry, I don't actually understand what your question means. So if you want to maybe re-ask it, and we can ask if you can answer it later. So Monk is asking, sorry, more of a comment, like how Powping is storing them. Last one. Okay, question for both of us, guys. Does it make sense to you to conceptualize the off-chain storage of transaction data packets as an object that can be then pushed onto chain later on?
I think so, yes. I think, yeah, especially if it's malleable. I think that's pretty interesting. Because you could have many users do some stuff to it. So when the feature stuff first happened, one of the hand cash devs, he made a comment that it should be using the SIG hash flags with the crowdfunding model, which I 100% agree with, but the wallets do not, no wallets allow that currently. But that would be an implementation of what this question is asking. So you would basically have a Bitcoin transaction that's unpublished and let everyone contribute to it such that, say 50 BSV is committed to that output. And then only then does that transaction become valid to be able to broadcast to the network. So that's an implementation of this question.
I actually think it's a really interesting, fascinating question because it points to an engineering kind of analogy. So in coding, we have this concept of mutability and immutability, and of course we talk about immutability endlessly when we're talking about Bitcoin. So you know, a data object in code typically is either mutable or immutable, and some classes are designed to be immutable so that as soon as they're made, you have certain guarantees about the fact that they will never change. When you've got those guarantees, that allows you to safely do things that you otherwise wouldn't have been able to do. In Bitcoin, though, for example, Josh mentioned malleability. I mean, a payment channel, for example, is an example of a mutable transaction that's constantly changing and evolving, and the act of pushing it onto the chain is the act of locking it down and turning it into an immutable state. So really interesting question, because it highlights a very important property of what Bitcoin does in terms of that state transition from mutable to immutable.
In your talk with Craig yesterday, which I thought was great, Craig brought up a point that blew my mind about having multiple in lock time transactions that are all set to the same time, but the input could be the same. So you could have where a user's given a choice to pick only one of those, because only one could be valid. If as soon as one's broadcast, every single other one has been valid. I think that's super interesting.
Yep. I mean, it leads to the rather dynamite expression of a conclusion, which is that double spending has a valid use case.
Yeah.
Yeah, I'm sure that could create all sorts of ructions on Reddit if we went to the subreddit and said that. Anyway, I think we've run out of time. So thanks very much, Josh. That was a great talk and a really good beginning. And we will be back to commence the rest of the day's proceedings in a few moments. Thank you.
Thank you.
So we spend a lot of time in Bitcoin SV talking about use cases other than payments, but the title of the Bitcoin white paper uses the word electronic cash. So of course payments are important, but there's a whole lot more to payments than simply the act of moving money from one person to another. That process itself has quite a lot of steps and can get complicated in some cases. Handcash is a well-known Bitcoin SV wallet that have really been leading the charge in terms of usability to improve user experience for people who might be fascinated by Bitcoin SV, and sometimes people who really don't care but just want a useful way of processing payments. So to tell us about the Handcash Connect API, here we've got the CTO of Handcash, Rafa, ready to learn us something.
Yeah, thank you, Steve. Hi, everyone. I hope you are enjoying the weekend. Many interesting talks, and I hope you're finding inspiration. So let me start the presentation, share my screen. Yeah, so I would like to talk about how Handcash Connect can help you to find your next business model. So, of course, everything is about micropayments. Micropayments are here to fill the gap between what is free and what we consider regular payments, maybe nothing less than $5 or $10 or this kind of amount. Micropayments are in the range of probably something less than 1 cent to a few cents, something like 50 cents. And they can help us to catch all these small opportunities that we are not able to monetize right now because they are not cost effective. The problem is right now, maybe someone like Mike, he wants to join Bitcoin, he wants to integrate micropayments, and he just starts with something like, yeah, I want to do the hello world with Bitcoin. I just want to send something like 5 cents to someone else. And the issue is it requires so many different concepts, like the UTXO management. You have to learn how to use a script and how to use the elliptic cryptography. Then you have to learn about the simplified payment verification if you want your application to scale. And finally, things like how to broadcast the transaction all over the network. And even worse, how to manage users' private key. If you want to be custodial, non-custodial, all these, bunch of concepts that in some cases you get a really bad impression about Bitcoin because it shouldn't be so difficult. So this is the problem we wanted to solve. And with Handcash Connect, all these concepts and probably all these months of learning and investment, they can be just something like that, just pay. So you require some sort of user authentication token. And once you have the token, you have permissions to use the user wallet. So just with these few lines of code, you can make an actual hello world in Bitcoin in a few minutes. And how do we get the token? So I want to show you guys some small application. This is one sort of one-day application that we created internally in Handcash just to create some sort of a stress testing tool for the SDK. It's called PayPistol. So the process is you are inside the app in PayPistol, you press this connect to Handcash button, you're redirected to your Handcash account, you review the permissions, you give the permission to the app, and you're redirected back to the application. So now we can insert a note, and every time that we press this gun button, it's going to trigger a payment. It's as simple as that. So there's payment, 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 and we can go faster because we actually want to stress test our infrastructure. So you can go as fast as that. And as I said, it's something that they require a few hours, and they weren't like our best programmers. I mean, it's people that they don't even really know about the big concepts of Bitcoin. So I want to focus today on just on payments, and in particular, these 3 features: instant payments, payment escrows, and payment streams. So instant payments is probably the concept we are used the most. They are just real-time payments with no intermediaries. So the sender just can send something like 10 cents to the receiver, real-time, and that's all. Really simple. The code that you require is something like that. Is the hello world that I showed you before. You just have to specify, once you have the token, you just specify like the description for the payment and who's going to receive the payment. So destination, currency code, you can use fiat currencies, and you can also use Satoshis. And of course, you can use handles and any payment. The second concept are the payment escrows. So the idea with escrows is we want to make sure that the money is going to be in place at the time that the deal is executed, because at the beginning, we know that we want to pay 10 cents, but we don't know the receiver yet. So there's a bunch of use cases for that. So we decided to wrap from a high level perspective, this concept. So there are two main steps. Again, we have to initialize using the authorization token. And then the first step is when we lock the amount from the wallet, and eventually we process the payment escrow at the time that we know who's going to receive the money. So we can do something like we lock 10 cents, and at the end of the process, when we want to execute the deal, we can specify the receiver and maybe something like get a fee for the service for offering, providing the platform and offering the service. And finally, we have payment streams. So it's some sort of payment when we know who the receiver is, but we don't know when the deal is going to be closed. So we're going to be increasing the amount until we decide to close the deal. So we have 3 steps in this process. One is when we create the payment stream, we specify receivers, amounts, description, same as before. But anytime during the process, we can just update the payment stream, changing the different amounts. And then finally, we can just close the payment stream, and it's when the receivers get the money. So now I want you to just think about what you can create with this. And I will be showing you different use cases, different ideas that we can explore to create new businesses and new products using these concepts. So the first idea I want to share with you is this concept of health data marketplace. So imagine that you can get paid for sharing your smartwatch data, like this one that I have here. So every time during the day, I'm generating some data that right now is not being monetized. And of course, this is something that is valuable. It's valuable for someone, for researching. There are many different purposes, but we don't have any way to monetize that. I mean, how much can you pay for that with the tools that we have now? But maybe now there's one opportunity to monetize this, maybe for a few cents. I imagine receiving a few cents every day just for being alive. The way we can implement this business model is using the instant payment feature. And it will be just something like that. The data buyer authorizes Handcash to spend money on their behalf. This is the token that we use. And then anytime that we find some set of data that matches with the data that this buyer wants to buy, imagine he wants to focus on people between 20 and 40 years, or just males or females, or some sort of criteria, is when we can just purchase more data. It's just a few lines of code. If you have any questions or anything, anytime, just we will be answering at the end. Just a small reminder. The second idea or the second concept are something like premium alerts. So imagine receiving alerts that are really rare, but they are actually valuable. And we can just pay a small amount just to get these alerts. One example of that can be pay to receive email notifications about cheap flight tickets. It's something that, of course, has value. Maybe it's not the unique idea, of course, but hey, it's something that maybe it deserves to be paid rather than just giving our personal information or any other alternative that doesn't seem to be working. We can just monetize these sort of alerts straight away. Again, we are going to be using instant payments in this case, and it's just a few lines of code. We have the alert receiver authorization token. So every time that we trigger the alert, the email is when we can charge the alert receiver. And it could be something like just one line of code split into 3 or 4, where the alert service is receiving the fee, this 5 cents fee. Another idea, competitive gaming. Imagine doing small bets every time you play to make the game like more spicy, more interesting. And it's something we can integrate everywhere. Connect is something that was built to be integrated anywhere. So we can integrate, this is a game that I used to play. I recommend it to you. It's called 11 Tennis Table. So imagine something like just betting something like 10 cents every time you play, and the winner gets the pot. In this case, I want to show you how escrow payments will be used. In this case, we have 2 different participants. We have player 1, we have player 2. So at the beginning is the same. For each player, we want to log the amount that is gonna be in the bet. And eventually, if player 1 loses, he has to pay to player 2. And in the other side, if the player 2 wins, he has to cancel the payment, the escrow. The money is back to the user. It's just that simple. The next idea, it's something we are actually used inside Bitcoin SV, is the concept of tipping content creators. But I want to give a different perspective. Imagine that we can combine something like Twitter API with Handcast Connect. Or imagine that we combine the YouTube API with Handcast Connect. So we can still get the network effect of massive networks with millions of users where all the activity is happening, but we can wrap it to add additional features. So you can create a Twitter clone app and add something like the ability to tip the content creator. I mean, we don't want to replace Twitter. We don't want to do anything. We just want to run this experiment of, hey, if both people have Handcast and I appreciate your content, maybe I can just tip you a few cents. In this case, we are going to be using instant payments. So again, it's something as simple as the follower, with the follower using token, we have access to the wallet and we just tip the amount we want. That would be all. I want you to focus on this idea of we can combine different APIs. We don't have to build everything from scratch, and we can take the most from the network effect of these massive social media apps. So we have the opportunity to improve what they offer. Who knows? Another concept, it's called like instant referrals, because normally referrals in referral programs, you get a reward, but maybe it's not cash, or you don't have the cash available straight away. It's like something that you accumulate inside the app and then maybe you can spend or something like that. One example of this is TonicPow. And if you don't know about TonicPow, it's like about getting paid for recommending products or websites in that case. So it's playing around this concept of, hey, you can get paid for recommending products. And the features that we can use in this case are, again, instant payments. So in this case, the token we need, the permission we need is from the referred service. And then every time there's a new referral for the for the product or for the website is when we trigger the payment. So in that case, the referrer will be receiving the money every time a new recommendation is detected. Another really cool concept, there's one company using it. They are called Kodak. If you don't know about them, what they are doing is they are offering a platform to monetize APIs. And this is the perfect example to show you how to use payment streams. So you have an API, and every time a developer is using your API, you charge them. So this is why this pay-per-call, it's called like pay-per-call business model. So we have like 3 main steps. First of all, in this case, the authorization we need is from the API consumer. Then at the beginning, we create the payment stream with the description of, imagine we have an API to get the shortest route between 2 points, and we expose that service in an API. So then who is receiving the money in that case? It will be the API developer. Or maybe if there's a service like Coda offering this, it would be fair to get a fee for them. And then every time there's a new request, so imagine that we open a daily window. So at the beginning of the day, we create the payment stream, and during the day, as we find new API calls, we increase the amount that is being charged to them. So at the end of the day, or like something that is arbitrary, we can finally close the payment stream. That would be the concept. I think it's flexible enough, and it just requires, again, a few lines of code. The next concept I want to share with you, they're called like micro translations. That's something we find really interesting because if you know, but Handcast, it offers different translations to different languages. And it's really hard because you don't really need a professional for that, because what you are translating, they are sentences. So you just have to translate a bunch of sentences. It's something that anyone that knows the language can do for you. And it doesn't really make sense to be paying something like maybe $50 just to translate maybe 20 or 30 sentences. Or, I mean, it's really hard. It's something really particular. So we thought it could be cool to have some platform that offers this micro translation service. So imagine you have something like Twitter, and as you find translations that match one of the languages that you know, you can just translate them, send, and get the reward. And the reward in that case can be just a few cents for every translation. So the description is getting paid for translating sentences. It could be something like that. And in this case, we can take advantage of the concept of payment escrows. So let's say the employer or the entity or the person that wants the translation to be done is the permission we need in this case, access to their wallet. And then 2 different steps. When we want to request the translation, we need to log the amount. There's going to be the reward. And once the job is done, is when we can process the payment escrow. And we can send the money to the translator guy. It could be something like that. And this is the very last concept. Maybe it's I think it's very interesting. Imagine that we can convert torrent into maybe something that we know is considered not very legal. We can make it actually legal. We can convert torrent into a distribution network. So the concept in this case is some sort of file sharing that rewards copyright owners and the sharing peers. So the copyright owners, they have to create movies and they don't have to care about how these movies are going to be distributed. So they don't need a platform that has to scale, or they don't have to care about that. The only thing is, every time someone, we still keep this peer-to-peer network to distribute the movies, but the peers that are sharing, that are offering the service so people can get access to the movies, they just get a cut. In this case, we use the concept of instant payments. So we have the watcher authentication token, the person that is getting access to the movie, and we split the payment between different distributors of the movie and the copyright owner or the movie producer or something like that. But the concept is, or the key idea is, the company that created that movie can be paid inside torrent. I think it's an interesting concept that is worth to explore. So these are all the concepts or ideas I wanted to share with you. And my goal today was just to inspire you to find new business models, showing you some, maybe some of them are crazy ideas, but I think they are worth to explore. And I want you to know I didn't want to talk about how to use Bitcoin or, as usual, it's just a few lines of code. And now it's time to focus on building. There's no limits. So just focus on exploring new business models and tell your not Bitcoin developer friends that they are welcome. And there's no excuses to start building on top of here. So thanks for your time, and I hope you find it insightful.
Thank you, Rafa.
Welcome.
I share my question screen. We've got quite a few questions have come through for you. And the first one I think is the most pertinent. When can we use Handcash Connect?
Yeah, so right now, the technology is there. The only thing is, our team has been working here non-stop for a long time, and we want to protect this technology. We think it solves many different pieces of Bitcoin and solving problems that they've been there for years and years. So we need to make sure we have the patents, we have this technology protected, and once everything is ready, it will be available. There's no one looking forward to it more than myself and my team, but it's not a technological problem, it's a legal problem. There's many copycats in this ecosystem, and we need to make sure we keep our competitive advantage.
Sure, okay. So any estimate? Are we talking a few weeks or a couple of months?
Probably a few months.
Yep, okay. So we have another question here, which I suspect you might have already stumbled on the answer. Do businesses like Coda, etc., are any of them already running Handcash Connect in beta?
I can answer that.
No. Okay.
I mean, it would be giving information about a company that it doesn't belong to myself. So
Yep, certainly. So someone's asking about the escrow payments. Actually, there were two questions which are pretty much the same one. With escrow, what happens when the two parties disagree about who should receive the escrowed payment? Is there a dispute resolution process or something?
yeah, that's part of the platform. I mean, like any other marketplace or whatever, the platform should define what's the policy for this kind of dispute. We offer technology to make the payment effective, but that's something up to every different parties. Yeah.
So that's defined by the user of the, or not the user, but the business that sets. Sets up
I think within the different businesses with the different contexts and the different business models, they require different policies. So maybe with our experience, we can recommend which policies to apply, but there's no. We offer the technology, but we can run the business for the other person.
Sure. Okay. A technology question then.
Nice.
John Pitts asks, what kind of backend languages can a developer use to integrate Handcash Connect, and how about straight API calls, no framework download? So I think what he means is, are there client libraries being built or being built in various languages? And is there, a REST API or some other generic API that people can use?
Yeah. So it's actually everything. It's on top of some REST API. We want to offer some wrappers for these APIs. Right now we have JavaScript SDK working on Flutter SDK, the technologies that we use. So internally we can test everything. But if you're using some programming language that we still don't have the SDK ready, you can just use the raw HTTP calls and done. So there's no limits. It can be integrated on the client side, on the server side, virtual reality, IoT. It's just HTTP. So no limits.
Great. The REST API, of course, is the universal language from which I think many language bindings can be built using auto-generated tools with it anyway. Before we take another question, I just want to let the viewers know about a feature that is coming to Bitcoin SV quite soon, which is probably quite pertinent to Handcash Connect, because you talk a lot about micropayments, and Bitcoin SV is capable of. Well, it makes sense to use Bitcoin SV for some very, very low value payments, simply because the fees are so low, less than 1/100 of a cent right now. So even half-cent payments make economic sense, but you can go even lower than that, because we're introducing the concept of a piggyback payment, where if you already have a transaction paying somebody, you can add outputs to the transaction paying very, very tiny amounts, even as low as 1 Satoshi. And the reason why that then becomes, the feature, I suppose, that makes that potentially usable is we're introducing the ability to consolidate many, many small outputs in a transaction that miners have the option of then mining for free. And the reason why they might do that is because it's a net benefit to the miner. If you take 100 tiny outputs and combine them into 100 tiny inputs and combine them into a single output, then you're reducing the size of the database that the miners have to use. So benefits them, and potentially enables a lot of new use cases, because you can build a business on the basis of receiving, a single Satoshi payment for providing some very, very microservice in large volumes. And all you really need to do is sit there and wait until you've collected enough of these small payments to make a consolidation transaction and put them all together into a more useful output. So, so Jenga asks, is building integrations with Twitter and Google, as you mentioned before, something that Handcash is planning to do, or do you think that other people would build these sorts of integrations using Handcash Connect?
Personally, I would love someone else to build these things, but it's something we internally are willing to do. My first Flutter app was a Twitter clone. So, I mean, we already have most of the pieces and we just need the integration of Handcash Connect. But we really believe on focus, and building apps, it's something someone else should do. I mean, we want to build some apps just to inspire people, to have some use cases in how you can build apps, to promote good practices and this sort of thing. But we don't want right now to build new businesses on top of Connect. We already have enough.
Sure, we have the same problem at Enchain. Focus is one of the key issues to contend with, and anyone who has not yet tried their hand at building a Bitcoin SV application, it's a very common process, I suppose, to get partway through building one application, and then by the time you're even halfway through, you've got an idea for 10 more. And so we hear this quite a lot when we ask, are you going to do this thing? Are you going to do that thing? Developers quite often say, I'd like to, but I've got these other 20 things I want to do first. So there's no shortage of ideas as to what useful things can be built as you start to explore.
Yeah, it's like focusing means saying no 1,000 times.
Certainly. So Chris asks a question which is probably relevant to any wallet-based service. Do you plan on extending the SDK to be able to recognize tokens on top of BSV? For example, tokenized run. Will the Handcash Connect protocol have integrations with those, or be able to recognize them at least?
Yeah, they are part of the roadmap. For now, we're really focused just on payments. We think there's huge potential, but once you have the base technology, it can be perfectly extended to token protocols.
Yeah. Thomas Zell asks a really good question here. Will Handcash Connect allow encryption and decryption of messages like MoneyButton and Baymail are currently doing?
Yeah, we had a few discussions about this feature during the last month. For now, it's something we don't think is necessary for the ecosystem we want to build, but of course, it's not discarded.
Sure. Again, focus.
Yeah.
Okay. We've probably got time for one more question. No, I'm told we've got a bit more time than that. So Monk is asking, do you see being able to sell your personal data, like your health data, as expandable to the point where it could become an alternative to UBI? I'm not actually sure what UBI is.
Like Universal Binary Interface? Or...
Oh, right. Yes. Okay. Anyway. Do you see a role for Handcash Connect in storing or managing access to personal data? Because it's something that wallets seems to be a natural fit for wallets, because one of their core functions is key management, which is integral to personal data storage, certainly in the MetaNet model.
Yeah. So let's say, if you want to build something like this platform to sell your health data, we are not managing this data, and it's something up to this business. Again, we focus on offering the technology to perform the payments but we don't see this data at any point. So we can control, we can have access maybe to the very personal information of the user, but not this specific data. So it's not up to us what to do with that data because we don't have access to it. Not sure if that makes sense.
I think so. So we've got a question. It's not a very technology question, but we'd like to hear your opinion. Do you think that a language translator could be something that someone who is actually learning a language could use? Could they earn money for, in the process of learning a new language? There was another question actually, which was quite similar, which was, could you envisage a place for a voting system where you could actually get many very cheap translations and allow the users to actually vote for the translation that was best, so that you can crowdsource the quality control?
Yeah, maybe we can combine the monetization of these translations with some sort of reputation system. So it's not just enough to send anything. In the long run, the quality of your job is gonna give you a reputation. So maybe we can combine them. If you're learning, but you are making a really big effort and producing quality translations, yeah, why not?
It actually sounds conceptually similar to BitQ&A and True Reviews. In that, it's essentially content production with a reputation management system. And both of those projects are looking at leveraging the blockchain to be part of that, and potentially expanding into leveraging on-chain identity as well.
Yeah, imagine something like also Stack Overflow. I guess you all know about Stack Overflow. So you can get, instead of just reputation points, that they are not bad, but hey, you could get a few cents for helping other developers. I mean, it's not enough to get 100, but every time you help someone, they could, or maybe appreciate your effort, or if you are the guy making the questions, you could just set a reward for them.
So we've got one last question here, which is again not a technical one, but I think that I'm sure you must have thought about this. If we start running large escrow deals using Handcash, how do we as users know that we can trust a wallet like Handcash? And I think that this question could equally apply to any service that provided escrows, etc.
Yeah, so I'm not sure what the question means with large escrow deals. Not sure if.
Well, I think they mean if we're escrowing $1,000 or $10,000, how do we know that Handcash, because Handcash participates in this somehow as the provider of the escrow service? Do they even need to trust Handcash? And if so, how do they know they can?
Yeah, so two comments. One is, this is focused on micropayments. So you want big escrows. I'm not sure that's the product that fits in. And the second is, it's our reputation as a company. I mean, if we have clients that we are not serving properly and we are scamming them or something like that, no one's going to be using Handcash Connect. So that's the incentive we have to provide the best service.
I think this is true, very much true, regardless of whether you're talking about the blockchain world or the traditional finance world. There are plenty of companies that we happily hand over large sums of money to look after on our behalf, and the reasons why we trust those companies are not actually anything to do with the blockchain. They're to do with the fact that the company's been around for years, decades. They have built up reputation over a very long period of time, and they've got an awful lot to lose by misbehaving. not just with reputation, but of course, there's legal consequences to behaving fraudulently, etc. So
Exactly.
just because you have blockchain attached to a business doesn't mean that this trust issue suddenly becomes any more important than it is in the real world. But blockchain, I think, or Bitcoin enhances the solutions to these problems because of the fact that you do have immutable records of everything. It disincentivizes bad behavior even more because there's an evidence trail that can't be erased. So,
Yeah, I agree.
so we have about 10 minutes until the next presentation. So rather than listening to me witter on for 10 more minutes, you might want to take the chance for a bathroom break or something else. Go grab a snack. And next up, we've got Brenton from Run to explain the Run platform, which is a fascinating tool and one of several takes on the explosion of tokenization tools that are coming in Bitcoin. And as a parting word, I've got a question that it wasn't actually put to me by Jimmy, not in this forum, but I've heard him say it before. So this one's for you, Rafa, and you don't actually have to answer it. In the context of blockchain, we talk about immutable more than almost any other word. And speaking of immutability, Jimmy wants to know what you use on your hair to keep it so perfect all the time. All right, so we'll leave it at that. We'll be back in a few minutes with Brenton and Run on Bitcoin. Tokens are a hot topic in Bitcoin SV right now, as they are in the entire blockchain space. But we're seeing the emergence of actual real and usable platforms right now. And I guess the idea of a token is to get things running. One of the really exciting token style projects that I've watched some of the development of over the last few months is run on Bitcoin. They have a really interesting take on tokens with a few twists. It's certainly something as an application developer you should be looking at to see if it's suitable. Because it is very much a platform that you can build a new application on top of. So to explain it to us, we have the CEO of Run, Brenton Gunning. Take it away, Brenton.
Cool. Thank you, Steve. Hi, everybody. My name is Brenton Gunning. I'm CEO of Run, lead developer of Run, and here today to talk about it on a technical level. I think most people haven't really seen Run yet, and so this is sort of a bit of a public unveiling of what it is and how it works. Now I realize that there's a couple hundred alpha testers that are currently using it. They know about Run, and there's a lot of people who don't know about Run. So I'm going to try to straddle those two groups and try to present an introduction for what Run is, and then also show a demo app and try to explain a little bit about how you can build a real app that scales using Run. So let me share my screen and then we can get started. Okay, so yeah, where to start? What is Run? Well, so Run is I described it as a platform to build apps and tokens on Bitcoin. It does a lot of things. The key thing about Run, though, are jigs. And what jigs are interactive tokens on the blockchain. And I'll give a demo of that. But there's more to Run than just jigs. In order to use jigs, use the Run library. This is a JavaScript library that you bundle into your application that lets you load jigs, create jigs. It actually lets you use other protocols too. Yeah, it can be your interface to the blockchain if you want it to be. And then there's Run services. These are optional services. They aren't required. You can use the library on its own, but we think that over time you'll find these services useful. But I want to dive into jigs, and I think probably the easiest way to do it is just to walk through our first tutorial for jigs. And so, if you go to runonbitcoin.com, there's a password behind it, but I'll sort of show what's behind this password. And what you get is a zip file. And in the zip file has the minified builds of the Run library for both browser and node. These will eventually be on NPM, but for now they're just part of the zip file. As well as the BSV library. Run uses this to create transactions. You have a few tools in here. There's a deploy tool to deploy code. There's also an explorer and some documentation and examples. But I'm going to pull up the getting started page of this, because the getting started page is actually a good place to test out Run and to try using it. So if you scroll down, you see some examples for jigs. There's documentation in the Explorer. But the cool part is that this file itself is a development environment you can use to test out Run. And so what we'll do is we'll go over to the run.network. This is our first tutorial on it. And the tutorial basically has you create a really simple jig. And so that's what we'll do here today. So scroll down. First thing we want to do is I just want to show you what a jig is. So we get some high level idea. We'll paste this address into the Run Explorer. And what this address will do is it has some jigs in it. So we can see that there's, this is maybe for a game. There's a couple weapons and a pet dragon. There's actually 5 jigs at this address, and these are basically 5 tokens. And if you click on any one of them, let's click on the weapon, we can see properties about it. It's been upgraded a couple times. It has some damage, and it also is an instance of a class. And this is how we create jigs: is we define classes that define behaviors of our tokens, and then we create instances of those classes, just like object-oriented programming. So if we click on the weapon, we can see the weapon class here. And to demo this, I think we'll just open the browser console and try creating a new jig. So really simple. You type, you create a new instance of run first. And just for this demo, we'll use the mock network. Basically, this is an in-memory blockchain, great for development and testing. And it's also really fast locally. So create a new instance there, and then we can start creating jigs. And so our first jig, let's create a dragon jig. And we will have a single method on it that lets you set the name. So you can imagine this is maybe you're a game developer and you want to create digital pets. You define a dragon class, and then users can own instances of those classes. To create an instance of a jig, it's just a matter of saying new dragon. That's it. This creates a new Bitcoin transaction that publishes both the code as well as the instance for this. And we can see that because if we type dragon.location, this is a transaction identifier and an output index. This is located at 92E TXID and output index number 2. And then if we want to call a method on it, it's as simple as saying dragon.setName, give it a name. What run does then is create a new transaction for this. So the dragon now has a new location. And we can do this again and again and update our data, update our tokens over time. So you can see that, as we update, we get new locations. The dragon also has an owner, and all jigs have owners, and there's ownership rules that are common to all jigs. And these ownership rules are basically, if you own the jig, you can update it. If you own the jig, you can also create other jigs from it, and you can update other jigs from it. And if you don't own a jig, you can still read the jig. And so these ownership rules are common for all jigs, and they sort of form the foundation for interactive objects. So we can see there's an owner, and that owner is our run owner. But even in this simple example, if this was a Q&A, I'd want to take questions. And by the way, if you have questions about run, post them in the channel because I'll answer them at the end. But there's actually a form of interactivity between jigs, even in this first example. And the answer is that there's a class called the dragon. And the dragon class is also a jig. And so it has a location, it has an owner, and as the game developer, you might own this class, and your users might own their instances, and you maybe can update this class over time to give your instances new behavior, just like you would, maybe change a property on a class in your object-oriented program, and then your instances get that new property. Yeah, jigs are software objects, but they're also tokens. So let me switch over back to the slide deck again. Yeah, so jigs are tokens. They're individually owned assets. All tokens are assets on a blockchain, but they represent something else. And in Run, that something else is a software object. So we've tokenized software objects. That's the basic idea. And using a software object, classes and objects, functions, data, you can create anything. So in theory, you can create all kinds of things with jigs too. They're interactive. So jigs support, all the properties that object-oriented systems do, including composition. You can store jigs inside of jigs. You can do inheritance, polymorphism, encapsulation, calling methods and passing them to each other. All the things you would just be used to doing with your objects in JavaScript or Java or any language, you can do with jigs. Jigs are based in JavaScript today, but the principles are shared across object-oriented languages. They're permissionless, so this is kind of key. The Run protocol is a layer 2, basically a colored coin protocol like SLP, except it's like SLP on steroids. It can do way more than what SLP can do. But what this means is that they're permissionless, meaning there's no server involved, no server required to perform actions on your jigs. If you own a jig, you can do whatever that jig allows you to do with it. And this is really key because one of the principles that Run is going for, one of the goals Run is going for is to make apps that interact together, that safely build upon each other's data, and users can bring their data from one application to another application. And so having users actually own their stuff and not be relying on a third-party server to use them is sort of key for that. They can be both classes and instances, and they must follow ownership rules. And if you want to use jigs, as I mentioned, you bundle the Run library into your application. There's a lot of different ways you can use Run, and Run is opinionated in a few places, but not that many. You may want to have, all of your application logic in a mobile app, and that is one possible configuration. But you may also have a server, and you may have tools that you use. And for all these different use cases where you need to load and use jigs, Run is designed to be flexible enough for these different use cases via plugins. And so all of the external views of the world that Run needs, including access to the blockchain, access to your owner keys, access to your purse keys, access to a cache that caches your state of your jigs. These are done through APIs, and you can configure them and actually implement these APIs however you want. And so we saw that with the mock network, that is a blockchain implementation local to your machine. What else? Okay, the library has the Run protocol, so it's also interpreting Bitcoin transactions and making sense of the jigs in them. And yeah, it has a feature called berries. I'm not going to really get into this, but it allows Run to interoperate with other protocols that are on BSV. So that's sort of an introduction. What I want to do now is show a demo of Run working in practice. And Run doesn't ship with these demos, but we have a bunch of different demos that show different things. I think I'll jump over it and show what this might look like. So here we have a project. It's going to be a game. And this game will have both a client and a server, which I'll show in a sec. And to get started, we just created an NPM project for the server. And this NPM project has a single index.js file with the logic for this server. And so I'll just go ahead and start that up now. So the server is started. We can go over to our web browser and check it out. This demo will be public when Run launches. So, and there's 10 or 15 other demos too. So you can think of these as like starter projects for real applications. Okay, so this is an idle style game. Idle style games are really well suited for blockchain, in my opinion. The basic idea behind them is you can perform so many moves in the game per day or per hour. And what you're trying to do is you're trying to upgrade something you have to its maximal state. So they have, maybe you're upgrading your theme park, or maybe you're upgrading your city. And basically you can only perform so many moves per hour. So it gets you to keep coming back. And that's why this style of game is so freaking addictive. And this is an example of an idle style game that shows maybe a planet. So maybe you're going to upgrade your planet over time. And kudos goes to Glenn Wolfe, because he was the one who pointed out that these idle style games are just so well suited for both Run and also for blockchains in general. So if we're a user, let's say we've already logged in. We didn't show that here, but we've already logged in, and we go to create, we'll pick a planet that we want to use. In this case, maybe the red planet. And every planet will have some resources associated with it. So this red planet has 4 metals and 1 energy that you can mine. And to mine them, we'll spend some of our coins. So if I click mine, what we get is we get the resources out from this, and we have to spend our coins to get these resources. And every 10 minutes we get more coins, so then we can mine more resources, and then we can take these resources and we can go and upgrade our planet with different upgrades. And so here we see a selection of upgrades that we can do to it. Maybe we click the volcano, and now our our planet has a volcano. That's all you can do in this little demo. But I want to use this to kind of talk around a few things about Run. So the first is that what makes this maybe different than other idle games is that users own their data, and they can take their data with them outside of the app. And to kind of show this is, I have this little spaceman down here, and we have an address, and we can take this address and go over to our Explorer again, paste this address, and we can see that we actually have, all of our items in this game, and they're owned by this address. And what this lets us do is now, because the players actually own their data, they can even do things that the game didn't originally intend. For example, maybe I build up this planet over a year or so, and it's really far along, and I want to go sell it to somebody. I can do that. It's my data, it's my token. I can go do whatever I want with it. The same is true for all the resources. Maybe this could be part of the game even. Maybe these jigs, in order to get to the maximal state of your planet, you have to trade with other people for their assets. Maybe your planet can't get you all the way there by itself. And so this demo doesn't have that capability, but it would be really simple for someone to build that, and the game can't stop you. And so that's kind of cool. And all of these are jigs, and they're individually owned. Now you might ask, like, what is the role of the server in this game? And it's a good question to ask in general. Like, what is the role of servers when apps are built on the blockchain in general? Do they even exist? And I think the answer is yes. I think servers will absolutely exist in the future, but they'll work in partnership with users who own their data and the blockchain that timestamps this data. And so in this example, the server is creating new coins for the players every 10 minutes, just blasting them out. And the server is also keeping track of all of the actions done in this game. Because maybe, for example, you want to have a search feature that allows you to find all of the jigs of a certain type in this game, and the server would be responsible for knowing about all of the jigs and making these available to the player. But the server also has a third role, which is helping the application scale. And we'll come back to that. But before we do, I just want to kind of explain, like, if we were to build an app like this, where would we start? And the first place to start is to think about, what are the items in this game? What are the assets, and who owns them? And so, we have a planet. This is owned by the player. We have all these resources that are owned by players. Upgrades, obviously owned by players. All this stuff is owned by players. What the game's going to own is the game's going to own the classes themselves. And so I'll jump over to the code for this. Inside of this demo, we have a jigs.js file. This has all of the jigs that the game supports. And so won't be able to talk through them all, but maybe a couple of quick things. So here we have a planet base class, and then we have 3 different extensions of that planet. So we have the red planet, the blue planet, and the yellow planet, each with different resources on them. And you can see how we specify that here. The planet is kind of interesting, though, because the planet is, by default, if a class exists on the blockchain, anyone can create an instance of it. That's just how this works. And so we don't want maybe anyone to just create a planet for free. Maybe we want to require a payment to create a planet. Maybe that's how the game makes its money. And so you can see that as part of the code to create the planet, this is the constructor, the init method, we create a game payment that pays 10,000 Satoshis to the game. And you could do this with every action if you wanted to, but in this case, we just do it when we create the planets. And the other thing that you can do with a planet is you can mine its resources. And mining a resource costs some amount of coins, and then it gives you those resources back. So that's basically what this code does here is you pass in a coin to it. It checks, is this coin a game coin? So it's not some coin from some other app. It sends one of those coins to the game server, and then it creates all of these resources. And this is an atomic operation. It, either all of this happens or none of this happens. So the game would kind of define, what can these planets do, and then users perform these actions and create the transactions themselves. Similarly, we have some resources, water, metal, energy, and life. Maybe these inherit from a base element class. And one thing I want to show here is, as I mentioned, users can, or, in theory, anyone can create any instance of a class, and it's up to the game developers to kind of set the rules for what the assets, what the jigs in the game can do. And so in this example, we see that the game developer has specified that only planets can create resources. So we actually check, is the caller, which is a special keyword in run, an instance of a planet? If not, throw an error. And this will prevent anyone else from creating water and energy just on their own. They have to create it through a planet. And this sort of enforces some of the interactions between jigs. Let's see what else we have in here. We have a coin. This is a fungible token. So maybe this could be used as like an in-game currency. And yeah, we have a bunch of upgrades at the bottom. And so, yeah, so the game developer will create this. They will deploy this code to the blockchain. When they do deploy it, all of these classes get locations, and this sort of uniquely identifies them, as we can see down here. And yeah, that's sort of step one. But then a lot of people have asked, how does run scale? Because it is a layer 2, basically a colored coin system. And if you've used other colored coin systems, you know that if you want to load a particular output, if you want to load a token, or in this case, a jig, you've got to walk back the transaction graph, loading everything else that depends, that token depends on, in order to recompute the state of the token in its latest position, or to validate it that it's correct. And so that process obviously doesn't scale. It's basically the more you upgrade these planets, the longer it takes to load them. And so I want to kind of show you maybe how you can solve this. So if we jump over to our Explorer one more time and open up the browser console, let's imagine we created a new new instance of run. Oh, hold up. Okay, there we go. Too fast. Okay, new instance of run. And then let's say we're going to create like a social media app where we have some posts. So we'll create a new post class and then a new post instance. This post has a location. And if we were to look at this at a blockchain, we would see a Bitcoin transaction that has basically an output that is for this post, as well as a special op return data that has the payload that describes what is in this output. That's how all op return protocols look. Here I have a picture of it. Yeah, all op return protocols have, all layer 2 colored coin protocols have a special payload, is what we call it in run, and this metadata has information about what's in the individual outputs. And so I want to pull up that payload. I just saved that so we don't have to go through the trouble of it. This is in the latest version of run 06. And what is in this payload is basically every run transaction is a small program that operates on tokens. That's how you can think about it. And this program did 2 actions. It deployed code, which we can see here, and then it created a new instance of that code. And when you go to load a jig, when your application goes to load a jig, it has to replay these steps. And these steps might depend on previous jigs. So there might be inputs to this program that have to be loaded, and that might spin off more loads. So this doesn't scale. And in my mind, I don't think users are ever going to be loading their jigs by replaying histories. It's just not a scalable approach. But we have a second option. And the second option is that at a given location on the blockchain, there is a particular state associated with that jig. And that state is cached. That state is cached both in the user's local machine, and then Run also offers a state server that can cache these things globally for all jigs. And these caches can load jigs really quickly. So I'll show what this looks like. Here's a class. The details aren't really that important, except that you can see that this is a code jig, and the source code for that code jig is down here at the bottom. And then we have a bunch of properties on this class too. And from this blob of data that is our cached state of the jig, we can very quickly load a jig. And that's going to be key to actually using jigs in real applications. Now you might wonder, okay, so if servers are just giving these blobs of data to recreate their jigs, where's the security in that? And the security comes because in every run transaction, there is a hash of the state. And the users create these transactions. And so the users know what their state was when they published their transaction. So if a server is going to provide them with their state, then the server state has to match what is in the Bitcoin transaction that the run user created. And this is basically how I see apps scaling in the future. If we go over to this slide deck, I have a little picture. This is how the demo works. Essentially, we have a client website, a server, a node application, and both of them are using the run library. So the clients are using the run library to create and load their jigs. The server is using the run library to load all of the user's jigs and cache the user's jig state. And so when the user refreshes their page or they go to a different device, their client will ask the server for the state of their jigs and validate that they are the correct state in the Bitcoin transactions. And so the role of the server then becomes not just to perform the actions in the game, not just to index jigs, but also to quickly cache the state for users and serve this up quickly. So that's basically the idea. Now, in this demo, I didn't show it, but in this picture, we have a third-party wallet, maybe being used to own your jigs. This could be, Relay has support for Run today. Money Button has, some partial support already. Dot Wallet is making good progress here. We hope to have all wallets support Run in the future. And the idea there is that users would, when you build an application, users would log into this application with their wallet. Their wallet would have the private key for that application. And from there, Run would be able to get all of the jigs for that user without having to ever see the private key. And so this is how key management might work. And on a server, obviously, you might want similarly hot wallets and cold wallets, same thing. So I think that's the end of this application. I'm happy to take questions on this, but I realize that I guess there's one more thing I want to show here. Yeah, so, okay, so how does the client and the server interact with the state cache? And so if we go to, let's see, if we go to this index.html, this is the client's website. Here we create the run instance. And what we do is we pass in a custom implementation of the state cache, as well as the blockchain, but you can see particularly the state cache is being passed in. And if we jump over to the code for this custom state cache, basically what it does is every time Run needs to load a jig, it's going to go to this cache first. And the first thing it does is it checks, do I have this jig in local memory? If I do, great, return it. If I don't, maybe I have it in the browser's local storage. That way, if the user refreshes their page, they're likely to still have that jig state available to them. So then we check there. And then if both of these locations fail, only then do we go to the game server and say, okay, I don't have the state of this jig. I don't want to load it myself. Can you tell me what the state of this jig is? And then the server will come back with a response. And on the server side, every time a Run transaction is broadcast by the user tells the server about that transaction. And that gives the server a chance to load and cache that state for the future. And so up here, we have a custom blockchain implementation that notifies the server every time they perform an action. So this works today, and in fact, maybe the server doesn't even have the state cache, and so we could imagine that if the server doesn't have it, maybe it happened too quickly, then the run library would go and replay the transaction. But that really should be an edge case that shouldn't happen too frequently. And you can actually turn that off completely if you don't want users to ever replay transactions by running them step by step. So I think that's all I want to cover today. These servers, you can obviously build a state cache yourself. That's no problem. But I think this will be so common that most people are going to want this to scale that Run's going to offer a global state cache for all applications. This is one of these services that Run will have as part of its business model. In addition, we'll have an Explorer. A pay server allows applications to not require that their users have BSV. So basically in this demo, I never had BSV. And well, I did, but you could build this where you never need it. And basically the server could pay for every transaction for users, and users then could maybe, with a credit card or something, buy the BSV or buy tokens from the server that would support them to do that. So the pay server is another server. Run has a blockchain server. This is optimized for Run. And last, we'll be launching a query server. So if you don't want to index jigs on your server to say questions like, find me all of the upgrades of this particular class, Run will index these jigs globally for all applications. And this is doable at scale. It looks like it's doable at scale. So I think that, if you don't want to set up a server yourself, there will be options for you just to get these services. So what's the status of Run? Well, we're at 0.5, and this has been a long time in development, and 0.5 is still private alpha. 0.6 is going to be our first public beta, and it's coming soon. We're talking weeks away at this point. And so the big thing about 0.6 is 0.6 has a stable base protocol that gives us the assurance, Run the assurance, that we can support all jigs in the future. It's still extensible, but it's going to hopefully go the distance, and jigs that you build today are going to work forever. So our goal is to get 0.6 out as soon as possible. There'll be a spec, the protocol will be open, and if you'd like access to this, go to runonbitcoin.com. We just added a link on the website that you can request beta access to it. Just click here, submit your email. In a few weeks, when it goes public, you'll get an invitation to give it a try. And lastly, after 0.6 goes to public beta, there'll still be a little bit more time to probably respond to feedback, and then we'll have some sort of public launch in the fall. This public launch will involve a wallet support, so you'll be able to log into your applications with wallets, and it'll also be open source. And so, the code is in pretty good shape today. It's not that big, but it is complex, and so we're going to try to clean it up and make this a project that many teams can come and contribute to, and hopefully use in their own ways over time. So that's the status of Run, and that's the end of my talk. So happy to take questions at this point.
Thank you, Brendan. Brenton, sorry. It's the second time I've done that. Would you mind unsharing your screen so I can show the question screen?
Absolutely.
Okay. So I've got quite a few questions have popped up. It looks like you've piqued some interest. I certainly sympathise with the hard decision that you have to make in the near future about locking down the API. This is a problem that every developer faces at some point in their career when they start developing platforms and libraries for other engineers to use. You always know that you're going to come up with a new idea, but at some point you have to decide that what you've got now is going to be backward compatible forever, or at least until a major release. So the first question is actually a comment, but I think it's worth relaying. Kevin says that this is amazing. I'm very glad that I caught your segment today, and I think that this will work well with something that I'm considering building. So he also adds a thank you. So I suspect you might have another beta tester
Thanks, Kevin.
There. Yako asks, when other people own classes they pay, what stops them from copying it somewhere else and uploading it to BSV through a different channel?
When people use own classes, they pay. So you don't have to pay to use a class. In the example, I had the classes have some code that to create the class, they had to make a payment to the game. But that's up to the developer to specify what they want their behavior of the classes to do. Let me read the second part. What stops them from copying it somewhere else and uploading it to BSV through a different channel? Well, every class has a unique location and a unique origin. And there may be two classes with the exact same code, but those are different objects. They're different jigs. And those different classes can be strongly typed and checked against. So if someone wants to create a class that is named the same thing or even has the same behavior, they can do that, but it's not going to be the same class. And the same is true for instances. Every object, every jig is unique and it has its own history that only the original developers is going to know about. So when you're building an app, you'll specify which particular classes you want to use in your app.
Mm-hmm. Okay. So before we move on to another question, another audience question, I've got one for you myself. I've got some ideas on the answer, but I'd like to know your take on this. So Run looks very different to coding something in Bitcoin script, not just because of the fact that it's a higher level language, but it doesn't actually boil down to script. It runs outside of the Bitcoin script engine. So firstly, why do that? And secondly, why? What do you see as the key differences between a script execution versus an off-chain execution?
This is an awesome question. So there are things you can do at layer 2 that are impractical to do at layer 1. One of those things is running JavaScript code. I guess maybe in theory you could compile that down to script, but it's not going to be practical. And so, to make these systems tokens easier to use, maybe we want these higher level languages to actually be the languages developers know, like JavaScript. That's one difference. The other thing is actually Run is not solely a layer 2 protocol. It's kind of a hybrid layer 2 and layer 1 protocol in that every jig has an owner. That owner is a Bitcoin script. And I didn't demo this, but you can assign your owner to really any script. And so we have multi-sig jigs that's possible. You can give your jig to a boost output. So maybe you have to mine your jig. That's a possible thing you can do. And you can actually create interactions between layer 1 and layer 2 through JavaScript and script. And so it's not solely one or the other. They kind of go together. And then the last thing is, when you compare Run tokens versus, say, layer 1 tokens, I think in practice they're actually going to have rather similar scaling properties. And the answer for this is would take longer than I have here to explain, but I don't think they're so different in practice that you'd want to prefer one over the other on the scaling properties alone.
Sure. Okay. It's really a matter of use case. I think I've seen lots and lots of different approaches to tokens over the years, and the one thing that strikes me is that people often forget about the context in which it's being used, because that very much affects some of the properties that are important. So Patrick has a question for you, Brenton. Can you elaborate on fungible tokens? What is important to think of, and do you have any experiences to share with regards to fungible tokens?
So fungible tokens are more complex than non-fungible tokens because they inherently have interactivity required, meaning you have some number of coins and you split them up, and you can also combine them back together. And so the token class that comes with Run is a fungible token. You can extend from it and add your own behavior to it. But the base class, what it handles is that interactivity of splitting up numerical amounts and then combining them back together. And so, if you were to write that code yourself, you could do it, but it is, more complex than a simple non-fungible token like a dragon or a game item. So that's one thing is Run will have a base class to make that easier. The second thing is, I don't know where people are going to end up using Run in the future. And so if we have a base fungible token class and people extend this, I hope that can be extended for lots of different use cases. But my guess is that once Run is out there and people can use it, they'll find use cases for the token that were not planned by the original token class. And so we'll have to upgrade this over time. And for example, fungible tokens, maybe you want to revoke them. That's a possibility. Maybe you want to have a blacklist for them. That's another possibility. Maybe when you send a fungible token, you want to require payment back to the issuer. All these are solvable problems, but they all require solutions. And so I think we're just going to learn over time, like how to do this in Run versus other platforms.
Okay. I think Thomas Zell has been thinking about the hybridness of Run based on this question. Do you think it will be possible to create a locking script or something that allows other people to call some functions of a jig but not to melt it?
Absolutely. Yeah, this is really cool. So the op push transaction technique that I think first time I saw it was by UShatters, but I've seen Xiaoyi and Script really take this idea so far, and it's so cool to see. That same technique can be used to restrict what you can do with a jig too. And the details of this going to be a little complex, or I'm not going to be able to talk about them here, but I absolutely think it is going to be possible to create jigs that you can only do certain things with them. And a good example of this is like maybe you want to give your users jigs that are prepaid, and you don't want them to just run away with the money, but you want them to be allowed to perform 10 actions on them before they run out of fees. And that might be a possible use case that you could use this with. And there probably will be others too.
Okay. Where's my question gone? Here it is. Sorry, it took a while for the slider to update. So jigs plus TXT plus overpool. Could you store transactions inside a jig, i.e. wrap script within a jig?
Sure, you could have a jig with a transaction side of it inside. In fact, that is one of the demos is showing an atomic swap. And in the demo, you actually send a user a jig that has in it a Bitcoin transaction that swaps a jig that they have with a jig that you have. And that transaction is partially signed, and they can finish signing it and publish it. And so we're using jigs to kind of enable permissionless atomic swaps between different users. But yeah, there's nothing stopping you from using jigs to you could have a jig that stores a wallet that has all of the jigs you care about. That might be one possible use case. And then as for TXT and overpool, so overpool is particularly interesting because it's basically like an off-chain transaction syncing system, and you should do that with Run too. That's actually a great way to scale your application, like what Powping is doing. I think especially for like games where you're performing a lot of moves back and forth, make those jigs, create the transactions off chain, make all your moves, and then when you're done playing the game, publish the final step on chain and in one big transaction. It's gonna be faster, and it's gonna scale better too. So yeah, you can use Run in all these scenarios.
You could possibly even collect all the transactions that went into the game and stick them in a Merkle tree and Merkleize them and create your own blockchain of games embedded in BSV.
Absolutely, you could do that.
We've got one last, time for one last question, and it's from John Pitts. Can you draw any parallels between? It's disappeared. Coming back. Can you draw parallels between Run and a relational database? Is this comparison not applicable or applicable? And he also says that Penn State engineering and science rules. I'm guessing that's an old boys club.
We are. I am from Penn State, and so is John, so that's cool. Run in relational databases. Oops, sorry, I just lost my screen. Can you still see me, Steve?
Yep.
Okay. Currently logged out of my computer, but that's cool that you can see me. Yeah, so a relational database is not, Run is more like a NoSQL database in that you have objects and like a key value store where the state of those objects is keyed by its location on the blockchain. And so if you wanted to do something like a relational database where you could make SQL queries and try to structure your jigs like that, you could certainly use jigs as a base layer to own your data. That is possible. You can imagine a database where every entry is owned by someone. That's possible. But I think in practice, you would build relational databases on top of jigs. And so you would have your jigs as your base layer for people owning data. And then you'd have a database that, say, indexes these jigs and says, have a master list of all the items in your game and what classes each one is. And that would be ran by a game server in order to make their users happier and their applications more functional. So yeah, kind of separate, but maybe useful. Yeah.
I think there's actually an interesting analogy between the NoSQL database versus the relational database in that relationals are known for normalizing data. That is, you try to only ever store a piece of data once, and if you need to use it again in another data structure, you use a reference to the canonical location of it, whereas the NoSQL database says just store copies of the data close to where you need them, which is a performance improvement. Of course, it comes at a storage cost. But I wonder how this is going to connect with the concept of off-chain and on-chain storage. On-chain storage, of course, has a cost. So it would seem that the normalized data storage model would be more of a natural fit. And perhaps it's the indexes and the I guess the replicated objects that could live in off-chain places. I haven't thought through this much, but it just seems like a natural mapping between the two models. Anyway, we have a few minutes until our next presentation, so we're going to take a short break. Thank you very much, Brenton. I think that judging by some of the comments, your beta program is going to be well subscribed. And next up, we have the SCRIPT team. I'm hoping they're going to talk about Push TX, but the tool that they'll be showing off is very cool indeed. So we'll see you in a couple of minutes for a demo.
Thank you.
So yesterday you saw some of the horror that is native Bitcoin script when I demonstrated it in its raw and unfettered form. Something that we have been sorely needing in Bitcoin SV for forever almost is high-level languages, so that people can build functionality in script with ease. I first met Xiaowei from Script quite a few months before Script kind of made its first appearance. And in fact, our very first conversation was about the desperate need for high-level language compilers. I had no idea that he had gone away after that conversation and just decided to get on with it and start building it. But I was certainly pleasantly surprised when I found out, and the progress and the leaps and bounds that him and his team have made have been nothing short of astonishing. So to show you what I personally think is one of the coolest tools in the Bitcoin space, we have the CEO of Script, Xiaowei Liu, to demonstrate for us.
Okay. Hello, everyone, and very thanks for the introduction, Steve. And I hope today I bring some more good surprises to you by showing what we have our progress so far. So, hello everyone watching. My name is Xiaohui Liu. I'm the creator of Script. So basically, we are a startup in this BSV space offering integrated smart contract solutions. So let's get started. So today's topic is about developing smart contracts on Bitcoin SV. So when people usually regard Bitcoin or Bitcoin SV, they don't usually regard it as some kind of a platform that you can develop apps or contracts on. You usually think of as just pure money transfer. So today I'm going to show you, besides the money transfer aspect, the other aspect, whether yes, you can actually develop a lot of actually arbitrary contracts on top of this BSV platform. So I think yesterday, as Steve and Craig talked about, yesterday is more about the theoretical aspect of Bitcoin SV. And today, and especially my talk, will be a lot of hands-on to show a lot of demos, and we can even start writing some simple code. Oh, sorry. Okay. I forget. Okay. How about now? Okay, thanks. So I will walk you through some of the first, give a basic sense of what the Script, the languages, it looks like, and then I'll walk through the whole workflow to get you from set up the environment until you start writing some code. You can test it, you can debug it, and then finally you can be practical. You can deploy the contracts on chain and call it just like any other contract you have encountered so far. So before I dive into all the details, so first give a high level, what is the contract on top of Bitcoin? So this model is a little bit of a unique because it's based on the so-called UTXO model. So if you look at the transactions, usually Bitcoin transaction consists of inputs and outputs. So think about this way. One example would be when you send a Bitcoin. So you are taking existing UTXOs, you are spending this, and you are giving, so let's say Alice sends 1 Bitcoin to Bob. So what it actually happens is Alice, the so-called, it takes Alex UTXO and then unlock the coins inside the UTXO and put into new UTXOs. And in these new UTXOs, only Bob can unlock. So if you zoom inside each UTXO, as we do in the example here, we have transaction 1, transaction 2. So in the output, the first output of transaction 1, you can think of that's a lock. So who can spend it? Only the person who has the corresponding key that can unlock the lock. You can unlock it. Only in this case, you can spend the coins inside. So that's how the Bitcoin's contract works. So basically, you can, as yesterday we gave some introduction to script. So basically, for each UTXO, basically Bitcoins, there's a lock on top of it. There's a lock in it. So the lock is expressed in native script. And then when you unlock it, you plug in the key, which is also a script. So you combine these two together. If you run them, if it returns true, then you can successfully spend the coin. Otherwise, you'll be rejected. So this is, as yesterday, I think a lot of speakers covered the script side. As you can see on the right side, there's some examples of some non-trivial script. So you can think of anything that you want to express in this smart contract, you can actually write it in native script. That's in theory, you can do everything in script, but there's one slight problem. It's like assembly language, right? Is as Craig yesterday also talked about when he talked about the origins of script, is more like assembly. It's a low level. So it's when he first even designed it, it's never intended to be used directly. So it's always the case there's some more abstraction like script, which is a high level language. If you look at the left of the screen, so you can get a sense it's more or less look like JavaScript, or some people may heard about Solidity or other kind of a modern language. So you can have defined variables, you can define functions. Instead of, you can also have types. So that makes it more friendly to developers. So script is, you can think of as a functionally is equivalent to script, but the only thing is builds on top of it and builds a wrapper and syntactic sugar on top of it. So you don't have to deal with the assembly level, low level, this esoteric language, which I don't know about you, but I don't usually like programming in assembly. So let's just walk through one example of like a hello world contract. What does it look like? So in this example, I put the so-called contract demo. So it's a contract is similar to class in object-oriented programming languages. So for example, again, also you can define X or Y here as properties, or you can say it's state variables. Of course, you have constructors to initialize these variables. And also you can see that's one example I show here. You can define functions. For example, you can define sum. So basically here, you can intuitively see the language is pretty self-explanatory. So basically you have integer A and B, and then you can sum them by just plus, and then return it as the result. So I think the thing I highlighted here are some of the unique features for script. So you can see some functions, they have this modifier called public. So what does it mean? So the contract, right? Like any other contract, smart contract, you have seen other blockchain. So basically the way you use it, you deploy it, and then you call it, right? So what public means, so for these functions, not only you can call inside script code, but you can also call it from outside of the script code, which is by sending transactions. So this kind of functions, you put a public in front of it. So in this case, we have a add public function. We also have a sub public function. So inside this, there's a statement called require. So for a lot of other, for developers coming from other platform or in general, this is similar to assertion in a lot of languages like C++ or even JavaScript. So basically this is a statement that this is the function that takes a Boolean expression. So if this expression is true, it will do nothing. You just keep running. So if it's false, it will fail the whole thing immediately. It's like assertion. So how does this contract map to the locking, unlocking we have mentioned previously? So basically for each public function, the body you can think of as they will go to the locking script part of the contract. And whatever you plug in for the arguments is in the unlocking script. So in this case, the easiest way to think of is the int z that will go into the unlocking script. If that is equals to the sum of the x and y you plug in earlier in the locking script, then you will unlock. Otherwise, you will fail. So next, let's get some practical. So in this example, I will show our IDEs. So let's switch to the VS Code. So we have released actually 2 IDEs. One is the desktop version. So you can see here. So for people who are not familiar with VS Code, so this is the one very popular IDE, if not the most. So basically, the biggest advantage is you can have you can support any language by install its corresponding extensions. For example, here, in this case, once you download install the VS Code, you can go to extension market here. And easiest way to support AppScript is just search AppScript. And then it will lead you to our extension here, which you can see. So after you can click one click, you can install, and then okay, I think let's switch to okay. Isn't it up now? Okay, thank you. So now we have seen the Visual Studio Code, and I showed you the steps to install our extension. Basically, you search AppScript in the extension market, and then you click install. Then that's all you have to do to get started. Nothing else, just one click, and you are about to enter the world of AppScript. So I previously showed the Hello World demo contract. So you can see it here. As usual, you can see all it's highlighted. You can hover functions. You can show the function signatures, inputs, output, return values, type. You can also hover upon variables. It will show you what is the type. You can also, if you press control, and then you can also follow. You go to this definition. So for example, here you have X, we can click and you can go back to X. And also you can, as you type, for example, I show some example, if you can start typing, you also give you the auto completion features as well. For example, here you can type I, you can import, you can type if, you can type integer type as well. So it's basically, it looks like any other standard IDE these days. You can get all the language features inside this with this one installation of the SDK. So now let me switch back to the slides. Okay. So besides the desktop IDE, we also have the cloud version. Basically, this serves as a different purpose. So this is for people who just want to, they just learn about heard about AppScript. They just want to start play with it immediately without doing anything else. So if you want just to try it out simply, so we have this cloud IDE called AppScript.studio. So you can click and go. I think let me briefly show it here as well. Okay, so show demo here. Show the web browser. So here we can go to script.studio. So this also is almost like a web version of the previous Visual Studio IDE I have showed. So inside here, you can also compile. You can also run it. And you can also, there's also a very nice visual debugger built in. So you can step through code. You can set breakpoints. So for example, if I can go next step, okay, I can also debug. I can run through different, you can see the opcodes, and also you can see how the stacks change. So another thing I want to mention is, so besides script, you can also run native script. So you don't have to write script code here. If you want to debug a native script, you can also type in here, and this gives you a very good tool to debug your native script if you want. So after I show you how you can write some contract and based on some of the basic syntax, so let's get what's the next. Usually in a standard software development workflow is you have a contract, right? You are playing with real money here. So you want to be very confident before you actually deploy this on chain. So what do you usually do? You write a lot of tests, right? But if you just use native script, yeah, you can do it. I mean, maybe with some of the tools, I think the Steve Shadders showed one way how you can play with it yesterday. But it's not that standard to whatever we developers usually use in our daily life, right? So for that to happen, we also build a testing framework. So in JavaScript, so if you are familiar with JavaScript, there are a lot of testing framework. So the good thing about us is for our testing framework, you can use any underlying framework you like. For example, you can use Jest, you can use Mocha, some people use Chai. And in this example, we just using Mocha as an example. So let me demonstrate how it works in this case. So let's go back to the Visual Studio Code. Okay, again, here we have previously we have the demo code. So on the right-hand side, I also show, let me enlarge this so you can see clearer. So for example, here in this demo.scripttest.js, we test this JavaScript in JavaScript code. So you can notice this, we have this, this SDK tool called the build contract class. So basically you tell which contract it is, and then it will be translated or in some other language called reflected into a native JavaScript class. So once it's reflected in the JavaScript class, you can use it as any other JavaScript class. You can use it, you know, this is essentially translated to calling the constructor here. So for example, here new, I give it 7.4. And again, then you can write expectations or assertions on top of this. So in this example, because I'm using Chai here, so you can see I'm calling the add function, the public function. I can call it. I can give it for example here, right? So I can run it. So here I can just try it on. Let's click run. Oh, this is also I installed another Mochai plugin that lets me just run it directly from here. I can show you ways to how you run if you don't have this extension. So of course here you can see because I used 7.4 to initialize this, and add is pretty much doing the sum. So if I give it a sum, it will be true. So what if I give it a wrong number? We expect, right? We expect it to fail. In this case, we can run here. We can quickly run it. Okay, now it's good, right? So this basically lets you to write the Bitcoin smart contracts as you write any other like modern languages like a Python or JavaScript or Java. And this very nice little tool we built, you can let you very quickly to test your contracts very easily. So as I mentioned, if there's one way is to install this extension in test runner. Basically, is a test runner. You can run it here. You can see all the tests. You can run them individually or by group. Another way, if you don't install any other extension, the easiest way will also right click and say run a script test. So we are running this demo. Okay, now also you can see this runs all good, right? So once you have start writing test, what usually happens? You are not, I don't know about you, but when I write test, it usually doesn't work for the first time, right? So for example, what if there's some bug in my demo contract? So if I put a wrong number, let's say if instead of putting 11, you can imagine if I put 10, right? In this case, what do you expect? Expect it to fail, right? Let's run it quickly here. Oh, okay. Now it says fail because 7 plus 4 is not equal to 10. So what we need here is, besides the testing frame, we also need a debugger, right? So let me show you how to run this here. So for this, because I want to use a more complex, more practical contract to show you this, I choose, there's another contract called, we have in our SDK we released called Ackerman. So basically this is more complex than the previous one. So I want to briefly demonstrate how you use this. So again, using, this is a standard Visual Studio workflow. You go to debug, and then in the dropdown, you can configure which contract you want to debug. And for this to work, you also need, I think this is all standard Visual Studio. This is not specific to script testing. So in VS Code, you can configure your debug using this so-called launch.json file. So basically the JSON file, you will specify what kind of tests you want to have, what parameters you have. So for example, I'm choosing to using Ackerman contract, and this is the constructor parameters I give it to you. This is the public function, which is called unlock. I want to call, and this is the Y value I'm giving. So once we have this configuration ready, we can start the debugging section. So before I start there, I think you can see around here, I also put a few breaking points here. So it doesn't just run immediately and finish. So let's start it. So you can go to debugger and choose Ackerman, or you can choose any other ones for here. I want to demo this one. So you can just click run, and then the debugger session will be live in, just give it a few seconds. Okay, now we are up. So you can see, we can go back. Now you can see on this screen, now it looks like any other debugger, right? So you have this control widget over here, which you can do, you can continue to the next breakpoint, okay? So we can set up, let's say, another breakpoint randomly here. We can go to the next one. We can, you can step by step, you can go to say the next step, right? On the right hand, you can see all the variables. We have class properties. Let me minimize this so we don't. Oh, you can on the left hand side, you can see all these variable values currently. You can see A, B. We have plugin. You have C local variables M and N, and also you can see some so-called block variables because this is decided within this if block. So you can see the top value here. And also, as usual, you can also set which kind of variables you want to watch. For example, here, I set some, you can set, let's say this B, you can watch it. I can, for example, I can change it, this B. You can watch, and you can also here see the cost stack. For example, this is the entry point. Now we are in this function called accrement. So you have unlock, you have accrement, and also this show all the breakpoints. This is like any other programming language debugger. It's no surprise. So also another way we can see is to interact with it through the so-called console debug console. So basically this is the repo. If you, like any other repo, you can, instead of compile and deploy and test, you can start playing with it here immediately by typing some expressions. For example, you can type some simple expressions in, this is as you are writing, as if you are writing a script code. So you can also start with this. This is the debugger we just mentioned. Let me switch back to the slides again. So we showed testing, and we showed when testing fails, what do? You debug. So we have the debugger session as well. How do you configure it, and how do you write and set breakpoints, watch variables, all this standard debugging techniques. This will help you identify, hopefully catch most of the bugs you can have. So, and eventually, right, when you have debugged, when you're writing a lot of tests, they're all looking good. What do you do next? You want to be real, right? So you want to deploy it on chain and try it. You put a contract, deploy your contract on chain, and then you call its the so-called functions, right, methods. So in order to facilitate that, so in theory, you can put the native script you can get from the compiler. You can put it manually into the locking script part, and then you can also compose your unlocking script manually. But it's a very standard way. We publish some SDKs to simplify all this, because this is the most basic pattern. So we want to make your life easier. That's the whole point for the script, is to make the developing smart contracts on BSV as easy as if you are writing JavaScript code. So let me go back to the code here as well. Go back. So let me first start the debugger. So coming back, again, let's say using the example of demo. For example, now I'm very confident this works as I expected. So what I do, I want to deploy it, right? So I have here got another file called demo.js. So basically this one will deploy this contract and call a few functions. This will basically put this contract inside one transaction, and then have another transaction spending the previous one by unlocking it. So again, it's only a few lines of code. We can, if you remember our previous test example, we also have the major one called a build contract class. So this basically reflect or convert the script contract into a native JavaScript class. So once you have that, you can easily see this is very similar to the test code. You can have the compiled code. You can put inside this, basically place this contract inside a contract, inside a transaction, sorry, and then broadcast it. And this is the first transaction by deploying the contract. And afterwards, immediately, you can go to the other step. You can unlock it. So basically, this one here, this is your locking script that's get deployed, and the next part is immediately unlock it. So let's try it on the real network and see how it goes. So I'm praying to my demo God. So let's see this. Hopefully this is live. So we'll see. So basically this is all part of the SDK. You can download this. I'll show you later where you can find this easily. So basically the only thing you need is plugging your private key. So for this, because it's demo purpose, I just use a testnet. So you can steal the test coins, that's fine. So the way I try to write, I already have some NPS. I also already write some script to handle this. So we can just run this npm script. So called npm run.testnet. Okay, this seems working now. So basically it shows succeeded on testnet and give me the transaction IDs for the 2 transactions. One is deploy the contract. The other one is to call the contract by unlocking it. So let's go to our favorite block explorer and just verify it actually works. So let's go to the browser again. And let's go to Watson chain that I showed here. You can, okay, find, okay, it's here, we found it. You can see this is pretty much, you can go to the, for looking at our contract, we go to the scripts tab, we can see here. So this is our contract, what looks like in native script. You can see it's not very human readable. Even it's not a big contract, you can see it's not very easy to understand. And the good thing is we already wrap up in a script. It's very easy. And also we can see it here. So previously we showed, you can get a little bit of numbers here. We showed when you deploy the contract, you initialize X and Y as 4 and 7. So basically in the end, in order to unlock it, you have to put the sum. So which is here is 11. So you can see that's why it gets unlocked. So meaning, okay, we have just successfully deployed our first contract and unlock it as well. All with just one line. We just plug in our private key. That's it. Everything else is done by our framework. So I just showed, I think, the little bit overwhelming lot of information here. So where do you find us? Let's go to the final slide we can show. So what we have done so far. So we have showed our IDs you can download. Then you can edit, you can develop, write your contract. After you write it, you can write a lot of tests. There's with it, using our testing framework, it's almost like you are writing JavaScript. And then I've showed you how do you do, if something goes wrong during the test, which happens most of the time, and how do you debug and fix it? And then once you feel confident this is working, then how do you deploy it? So all of this, you can find us on our website, script.io. So there you can find the formal, let me go to this website, script.io, and show what we have there. All the information I just showed is all listed there conveniently. So you can go to script.io. Okay, script.io, you can find our ID download links. You can find our web version as well. You can also find the formal specification for the script language, which I can show you briefly here again. You can show all the syntax, and I even have some examples. And one last thing I want to point out, you can also go to our GitHub. So by clicking here, this is where you find all of our SDKs. So for example, the most used one is this repo called boilerplate. So basically, the recommended way to start any script project of your own is to git clone this and use this as a standard boilerplate, just like what I have shown in the IDE as well. So lastly, but not least importantly, you can find us on all the social media. You can, I just showed you very like a hello world-ish examples. And actually you can, beside this very basic contracts, you can write any arbitrary contracts you can have actually on Bitcoin SV today. And you can have any other chain contract that you can write on any other chain. You can write it here, and it's much cheaper. I think it's, for example, I showed some token examples previously. So if you look at the transaction fee, it's about 100 or even sometimes 1,000 times cheaper than the transaction fees on other chains. And because we can scale, there's no, you never have CryptoKitty and blocking the whole network. You will never have it. And also we also have a lot of examples. For example, you can maintain state, you can do atomic swap, you can do articles, you can do insurance and inheritance. So for all this example, you can find on our medium.com, which we have released a series of articles to how do you develop non-trivial contracts. You can find here. And again, lastly, if you have any questions, you can go to our Slack channel and ask any questions there. So thank you. I look forward to hearing questions from you guys.
Thank you, Xiaowei. We've got a couple of questions. If you wouldn't mind, just unshare your screen so that I can show them.
Okay.
Okay. So not surprisingly, I've got a couple of questions of my own, but we'll get through the audience questions first. Firstly, actually here from Raoul is it's probably more of a question for Bitcoin Association, but it's an important topic. Raoul asks, is there any workshop or course to learn Bitcoin SV programming for normal people, I mean, without prior knowledge? This is certainly something that I expect a lot of people are going to ask over the next few months. So the short answer is there are some resources out right now, including the Bitcoin wiki, which you can find on wiki.bitcoinsv.io, which is a great place to start learning the fundamentals, I guess, of Bitcoin SV, and in particular, a great place to unlearn some of the ideas around BTC, which are actually just not applicable or just plain wrong when you're talking about Bitcoin SV. So that's a good starting point. But the Bitcoin Association has an education program in the works right now. It's well and truly coming along, and they're developing a full curriculum. So later this year, they expect to be releasing the first course materials, or actually courses that you can take. And the goal is for those courses to be available either as delivered in person or online, and other formats as well. And they're meant to target both beginner, intermediate, and advanced. So in the short term, the Bitcoin Wiki is a good place to start, and Slack channels, the various Slack channels and Telegram channels, the Script channel is a great place to find knowledgeable people. So you're not short of places to go to learn right now, but keep your eye out for that later on. So Xiaowei, Will Divine asks, can we make non-fungible tokens with the op-push-tx method so that each token could have a unique serial number?
Oh yes, that's a very good question. So as I just mentioned, if you go to our official website, and then which links to our medium.com series of articles. So the latest we've released is how do you use op-push transaction to issue fungible tokens, right? So with that example, it's not difficult to extend it to non-fungibles. So think about this way, right? So the fungible tokens is for each token type, for each token, for each owner, you can have a certain number of tokens, right? So when you transfer the tokens, you have to make sure the total number of tokens doesn't change before and afterwards, right? They have to equal. Whatever you have before, you have, once you transfer, you still have same number of tokens. So there you're comparing the numerical equality, right? So for fungible, the only thing you have to change is instead of numerical equality, you use set equality, right? So instead of each for example, each property, how many tokens you have, so it will be a set of tokens. So you have token A, B, and C, right? So when after you transfer, you make sure the set of tokens in the output is going to be the same. You still have A, B, C. And so instead of numbers, you have a set. So instead of comparing them equality numerically, you check the set equality. I think that you are not the first person asking this. So yeah, I may update it or write another article on how to do fungible tokens and give you some code. So very good question, yes.
Okay, so a couple of questions from me. As you know, I'm building a tool that's a long way behind yours in terms of its development progress, but it's also, I guess, quite differently targeted. It's intended for probably a lower level of programming, and I'm interested in how that might be able to integrate with script or be a useful tool for script even. But before we get to that, how do you have a model, I guess, in mind for code reuse? Let's say I wanted to build a sort of a functional library for, let's say for argument's sake, ECDSA math, elliptic curve math with functions like point multiplication and things like that that can be expressed in script. How could I go about doing that with script and then make a library available for other developers to use in their script projects? Is that something that you support now, or?
Yes. So there are actually two ways. One, you can do it now. The other, I think there's a new feature coming. So the whole thing we have, why we have the concept of abstraction as a contract is the number one reason is actually so it can be reused. So there's a syntax called import contract, right?
Mm-hmm.
So existing, you have, for example, you have a contract called bar. You have another contract called food.script. So in the bar contract, you can simply just import the food contract. Then you can share the code as it's like any other standard language libraries. For example, in your example, right? If you can write your code in script, then you can just share it on GitHub or anywhere, and people just download and say import. So going forward, you can even imagine we have our own package manager. It's almost like an npm, but it's Gradle for Java or Stack for Haskell. You can imagine we have our own package manager just for script. So it's almost like a unique, it's another package manager. So you don't have to go to GitHub or whatever. You can find this contract. You just npm install, say ECDSA. That's one way, right? If you can write in script, you can do it today by import your file, script file. So another way is, I think what you are hinting is you have your native script implementation, right? So you may not, for whatever reason, you're not writing this function in script, either because it's optimized or whatever. So there's another syntax where we're going to write. Basically, this is for low level, because script is high level, right? So, but we also want to people who's like you, they're already master of native script. So we are allowed this syntax called ASM. Is I think some other language like I think C and also Solidity also allows you to embed a native language with this little bit, if you know exactly what you're playing with, you can see we have this statement called ASM, and inside you can write native script. And this will be compiled directly into a script code as well.
Okay.
So yeah, basically you have one way which you can work today by writing in script. But if you only have script, I think that's one thing I need to add. This feature basically has ASM you can embed.
That sounds like something we should definitely have a talk about offline.
Yes, yes, we can definitely
have some ideas there myself in terms of the interoperability.
Okay.
We've probably just got time very quickly for one more question. I'll have to ask you to keep the answer short. Can you explain your thoughts on what Ethereum's Solidity plus gas solution missed in terms of allowing scalable scripting contracts? Is the idea good and the execution wrong, or perhaps the idea is just terrible in the first place?
Yeah, simple answer is wrong. So there are a lot of reasons. I think Steve and Craig covered yesterday why we don't. The whole point for gas is because you can have, you don't know whether your program will ever stop, the halting problem, right? Because for script, we don't have the ability to jump and loop natively. You can do a lot, you can build abstractions on top of it, but natively, you cannot jump back. So we never have this halting problem. If you can compile, it will halt because the script execution is sequential, right? So you take the script, you run from the first byte till the last byte code or opcode. If it's, you can always, there's no jumping back. So you can always sure it will finish because it's finite, it's fitting within a transaction, right? Versus Ethereum or Solidity or bytecode, there's a jumping instruction and looping. You don't know whether it will add. So it's a regress, I would say, to put it that way. We don't need gas. We don't need gas, and it's much simpler, more secure. You always halt.
For sure. Okay. Well, we need to wrap up now because it's only a couple of minutes until our next presentation. So thank you very much, Aowei, and looking forward to working with you more in the future. And anybody who wants an easy road into writing Bitcoin scripts, go check out script.io. Thank you.
Okay, thank you.
Well, no discussion about platform tools for developers would be complete without a mention of the enormous suite of tools that have come out from Unwriter, and for a long time just Unwriter on his own solo, but now Planaria Core. The Unwriter world is expanding. So today we've got Glenn Wolfe from Planaria here to talk to us, I think, specifically about the TXT protocol, which was released very recently, and maybe some of the others. I'm not sure, but I'm looking forward to hearing ways of making engaging with the Bitcoin blockchain easier from Planaria. Thanks, Glenn.
Yeah, thanks, Steve. Yeah, so Steve, so you're right. We're gonna cover TXT, but let me go ahead and share my screen. The plan is we'll get to TXT, but first I think it would be wrong to not first talk about a bit of history in terms of how we got here to TXT, and you know, I also wanted to talk about for people who might be just joining in or might be either new to Bitcoin development or maybe just new to the Planaria tools in general. I also am just going to touch a bit on our core suite of APIs, and then finally leading into sort of how maybe the future possible peer-to-peer future and how TXT fits into that. So that's the plan for today's presentation. And yeah, do want to encourage, if you do have any questions, write them down or ask me afterwards, or even if more questions come up later down in the day or while you're developing, I'll be available on Slack pretty much during the weekend, and so just reach out to me, and I'll be happy to answer, whether that's after the presentation today or later on. So well, let's dive right in. So the first thing I want to talk about, back, like I said, is just a bit of history. So first, like a quick timeline about like kind of how we got here. So first, we really have late 2018. That's when some of the early tools are being developed, which focus on building Bitcoin database applications, and along with a few kind of I have listed here kind of unfuckings of the Bitcoin protocol. We start seeing really rapid growth of the Bitcoin application ecosystem. And so many of these applications that are being built are built on open source tools. You know, some of which, as Steve mentioned earlier, were developed by Unwriter. And but yeah, the point here is that a lot of them are kind of, that's what they are. It's just is tools, and they do enable this really rapid growth. And so you might recognize some of these tools. Maybe you are still using some of them. So that would be like Neon, Kronos, Genesis, Bob, DataPay. But you know, coming up into the period of July 2019, that's really where sort of we notice a need for sort of a shift to happen, and that's and that shift is what we start seeing is following the growth of applications. We see a rapid increase in the rate of growth of data that's going on chain. So what this means is that we know it's time that, you know, the services, the infrastructure which is powering these applications also need to professionalize and get ready to scale to handle the future demands. So that leads us to part 2 of the timeline. So September 2019, that's around the time Planaria Corp is formed, and this is all leading up to February 2020. You know, I know the Node team was doing a ton of work to get ready for Genesis, but behind the scenes, so were we, because there were, you know, providing filtered data from the blockchain. We know what kind of future challenges we'll have at real scale. And so leading up to February 2020 with the BSV Genesis upgrade, that was also February 2020 was also a big moment for Planaria, where we released our what we call the grid. And what the grid is it's our core suite of APIs, which I'm going to talk a little bit about that later. And then finally leading up to you know, June and July, of course, the BSB DevCon. Well, recently we've also want to focus on giving application developers as many choices as possible. So while we want to make it easy to build fully Bitcoin-derived applications, we also fully peer-to-peer applications. And so we're going to lead into how TXT really fits into all that. So I'm going to go ahead and move forward. So the grid. So what is the grid? Well, the grid is our like I said before, our suite of stable and scalable APIs, which we are going to support into the future as Bitcoin grows. And so this is really a triad of APIs. So Bitbus, Bitsocket, and Bitfs. Bitsocket for listening and filtering in real time, Bitbus for querying, and Bitfs for large data. And so I'm going to do like just a quick sample on each of these three. And for some, this may be a review. For others, this might be new to you. But like I said, if you since I'm going to kind of go real quickly, if you have any questions or words, but hopefully this will be a good introduction and at least let you let you have an idea on what the tools you have at your disposal. So first I want to interrupt that and do a quick review of what TXO is. So TXO is essentially it's transcription and translation of Bitcoin transactions into a format that can be indexed and queried. So TXO has really two levels to it. So one is the transaction level. And so here you have items like the transaction hash, the block height index, the block hash. You have your input array, your output array, end lock time, and timestamp. At your next level is going to be your script level. So you're going to have your input, output attributes. So in each of those input and output arrays, you have your script level. And so within that, you have the input, the index within the transaction. So that'll be the topological ordering, sequence, edge. S attributes would be string, B is base 64, H is hex. So and then length. So again, I'm not going to go too deep into this. Oh, and another quick thing to mention that's not included here at transaction level is I is also included. So with Bitbus, you have the I attribute. So that's topological ordering within the block. So, but moving forward, and the only reason why I cover that is because it's relevant for what we're about to show, and so that is to make it possible to use BitQuery, which is a Bitcoin query language. And so it's really simple. It's basically if you're unfamiliar with it, if you're familiar with MongoDB's query language, then it's pretty much the same with a few added features, and really it's a small learning curve, so you can really jump right in. So anyways, moving forward, so Bitsocket. So Bitsocket is used for listening to the mempool in real time. So and Bitsocket order is based on timestamp. So let me just jump into a quick example of how we can use Bitsocket. So Bitsocket uses a Git-based API, and so like I mentioned BigQuery earlier, what you can do is you subscribe to BigQuery and then from the mempool in real time as the transactions hit. So let's give an example of what that looks like. So like a simple, the most basic BigQuery you can really have is just empty find. So yeah, let's give this, make sure that's all good. So this would be like a super simple BigQuery filter. And so what we're just going to do, just to demonstrate this, is we're going to just transform it to base 64. Okay, and then what we're going to do is I'm just going to use curl to demonstrate the APIs, because most of the time, I mean, you can use whichever language you want. That's what's great about having pure API based. But yeah, I'm just going to use curl. So HBS TXO. So and the socket endpoint uses /s. We also have a query endpoint where you can actually query that for the past 24 hours from the BitSocket database if you're worried you might have missed something. But again, like these are things which we can talk about more later. So here would be curling the. So what we see here is just transactions kind of as they're hitting the mempool. So ordinarily, you can imagine how you would use this is you would instead of having an empty find query, what you might do is you might include your bitcom here, your bitcom, and that's how you would use this to kind of to know when transactions are relevant to your application are hitting the mempool in real time. So that's my quick BitSocket example. Now moving forward to BitBus. So BitSocket. So you want to know as soon as something hits the mempool, but it's not really real. It's not really. It doesn't really have a place in time really until it comes into a block. So if you want to if you either want to sync with on chain or kind of ever want to resync your application, you can use BitBus's crawl or query endpoint. So we'll do a quick example of this as well. So let's do. Okay, so what I have here is let me just first show you what we're looking at here. So this is another just curl example. So where BitBus uses the post API. So first off, to use BitBus, you will need a token. So I have a token prepared here, but ordinarily, if you want to fetch that token, what you'll do is you'll just go to .planaria.network. It's really simple, and you'll come here and yeah, you'll just copy this down and that'll be it. But you generally, you're not going to want, unlike me, you don't want to usually screencast that. You want to keep that private. So anyway, so you'll include a token in header, and you'll want to let content type know application JSON, and then finally data. Again, this is going back. This is using BitQuery. So you'll use a filter which you want, and you will need to include with BitBus. You will need to include a limit, because obviously we don't want you to basically request the entire blockchain. So you will need to include a limit on that. And then here I'm just piping it to JQ just so it looks prettier when you see it. So what I'm going to do here, actually, is get rid of this. So what we're looking at right here is just a BitQuery for the B protocol. So for those that are familiar with the B protocol, and limit one. So I just this just returned and I didn't include a sort on this. So this just returned we crawled transaction. Looks like this one is from block 572,561. Here's your different attributes. Here's S0, so that's going to be a string. This is chunk index 0 for input array index. Looks like input array index 2. And anyway, so this here's your bitcom. So this is what you're going to use to query. So moving into a BitFS. Well, BitFS is for large data. So BitFS is meant to work in tandem with BitSocket or BitBus. So obviously, with people now posting all kinds of files and images, all kinds of large data on the blockchain. Well, oftentimes, these large data can't be fit directly into an index, but instead what we do is we include references to that large data in a deterministic fashion. So going back to this query, adding back in what I had before, we're gonna make sure that out.f3. So what I'm doing now is I'm including a filter for f attribute, and f attribute is used for bitfs. That means file. F stands for file, and again, the numerical is the chunk index. So that's the chunk index within the script. So what I'm doing now is I'm making sure that f3 will exist, and we're just going to get 1, and I'm going to use this one for a demonstration. What happened there? F3. What do I do here? It's here. Okay, I'm gonna show you this way. I don't waste time with that. So essentially, we do have an explorer. So the way this works is basically it's ordered by transaction out, and then output index, and then chunk index. So we can go to these pictures here. So like if let's say you have a bid, like you're filtering for your bidcom, and you see a f attribute, and you want to basically store that f attribute into a file on your server. Well, okay, then what you would do is let's take this guy. So our file API is x.bitfs.network, and then you have the transaction, output index, and then chunk index. So all you would do here is curl that, and then let's say file. Okay, open file, and you can have that on your server. So anyways, don't want to waste any more time with this, but you get the picture. So moving forward to part 3, which is the peer-to-peer aspect. So everything I've discussed so far has been kind of up till a few months ago. A lot of the core of Planaria was about fully Bitcoin derived applications. And while this approach has some really powerful advantages to it, we do want to give the developers as much flexibility as possible. And part of that is there is a need for peer-to-peer, and this has a big part in the future. And so to allow developers to work with that, we built TXT. So what TXT is it's basically it's a big transactional database, and it works as sort of like it basically is a database management system for which is tightly coupled with Bitcoin, and I'll explain what I mean by that. So TXT. So again, so what it does, it does semantic Bitcoin storage, but what it is a Bitcoin transaction DBMS. So let me first kind of unpack that a little bit. So TXT as a Bitcoin transaction database management system. So you might have heard of database management systems. You might have heard of these or even worked with them before. So an example of this would be Microsoft Access. So many of these popular database management systems have database applications which go with them, but you don't necessarily need to use the built-in database application to use database management system. TXT is much the same. TXT makes it extremely simple to just get started, building peer-to-peer Bitcoin transactional databases, and it has a nice built-in database application, which is where you can search and kind of explore. But you can basically build your own database applications on top of that, or on instead of that, for your users to interact with. So I don't have time to explain all the details of how TXT works, but I do want to give an example to just demonstrate the power, and a lot of that power lies within the end game here, which is the SQLite DB as a file. So this means that the databases generated by TXT in the spirit of peer-to-peer are literally files. So they are so portable. I could email this as an attachment, or I could literally just send it back and forth. And so this is really where a lot of the power of TXT lies. So to demonstrate this, I'm going to show an application that Unwriter recently released called BitCache. So what BitCache does is it basically exposes a wrapper around the TXT API, which enables you to, which lets you easily subscribe to query Bitbus, pipe that into your TXT database, and then subscribe to a BitSocket query to continually listen and write that in your TXT database. Meanwhile, and then you can basically share this share this as a file. So let's explore that real quick. So TXT, to use TXT, you do need two things. And then I'm going to use the Docker Compose just because this is just so I can it has inbuilt like the mount functionality for Docker volumes, which you don't worry about right now. But yeah, so you will need Docker. So what I'm going to do is I have my Docker Compose file here already. If you want to get that Docker Compose file to try TXT, first just install Docker Compose, and then just curl txt.network/Docker compose.yaml .yaml, and then write that into a file, and then you'll have that right there. I already have mine set up. At least I think I do. Or maybe I don't. Yeah, so anyways. curl-l. I not have it? /docker compose.yaml docker compose.yaml. Okay, so now I do. Okay, so here's what that looks like. Basically, I'm not going to spend much time on that, but now we're just going to do, first I'm going to get rid of that mount folder. And Docker Compose, okay, so what I have here now, this is just a so I'm just gonna go to localhost 3013, and what this is now is this is the empty TXT. So mentioned back here, back at this graph, this is what we're looking at. And so, like I said, TXT comes inbuilt with a database application, but the core of TXT is really in the database management system and the API that it exposes. So to demonstrate this API, first we're gonna try this BitCache example. So what I'm gonna do here is this is a BitPick cache. So what we're gonna do is basically we're gonna crawl all BitPicks using Bitbus, and then subscribe to a query which I like, similar to what I demonstrated with BitSocket, to listen for new BitPicks coming in, and we're gonna write these all into the TXT database. So let me run this. So we'll be able to see this thing pop. Yeah, so we see this thing populating pretty quickly. And within, let's see, all right, so what's happening now is BitPick, yeah, is pushing all these Bitcache is querying that, basically crawling Bitbus and pushing all of those into TXT. And yeah, we see these basically populate here, and I think this should be pretty much like, let's see, like Ryan at moneybutton.com. Yeah, so this is all here. So what we're going to do now is, since that's that's basically done, and the other advantage of BitPick is it works with the miner API. So what it'll do is it'll once you push all those transactions in there, it'll also crawl the miner API. You can see this happening now. It'll crawl the miner API, and it'll request for the confirmations on those transactions automatically. So that's pretty powerful. So you can basically have a signed proof from a miner, where this transaction actually exists on chain, or if it doesn't exist on chain. So TXT is pretty agnostic to that. So now what I want to show you quickly is, if I go into this mount folder, txt.db. So txt.db, this BitPick, this entire BitPick DB is 2.3 megabytes. So if I wanted to, I could simply take this file, and everything's here. My entire DB is here. So here's all the transactions. We see the data that goes along with it. Meta tags. So here's the money button users. And so you with TXT, you own your database. So and it's the portability is really critical here, where if we want to facilitate a peer-to-peer environment, the databases themselves have to be able to be shared easily. And so that's what TXT does. And so finally, next thing I want to touch on is sort of, I do want to give a quick plug to, we have a new mental approach for peer-to-peer, which is called PowPing. And this is really a new approach to doing peer-to-peer, taking it really to the extreme. So I encourage you to check this out. We'll be releasing more about the PowPing protocol in the future. I'm not going to say too much about it right now, other than that, you should go check it out. So let's see, that's about it for me. And so let me go back here. I want to leave some time open for, not leave. Let's see. All right. Yeah, I want to leave some time open to kind of just talk and answer questions. I'm not sure how much time I got left, but yeah, that's everything I wanted to quickly cover. And so yeah, now I'd like to see if there's any questions, and just talk. Steve, I can't hear you.
Oh, sorry.
Oh, there you are.
Thank you, Glenn. We've racked up a few questions here so far, so let's crack on.
Yeah.
Script asks, is Planaria planning to work on indexing and searching specific types of smart contracts, for example, R puzzles, and and then he says script hash is not enough. Oh, okay. Searching by script hash is not enough. He wants more granular indexes.
Yeah, we are like going to continue to evolve our index structure. So it's not set in stone. So I mean, we know that with we're really excited about script and yeah, all I can say is I can't give any details on what exactly the future plans are, but yeah, I'll say we will do whatever makes sense for the community and what people want. Yeah.
Cool. So next question, I think probably goes to that, and it's a really pertinent one because it gives a bit of a hint about which direction you guys are going. How does the back end of Planaria make use of SPV, or actually even does it make use of SPV? Is it going to use SPV, or do you envisage Planaria running a Terranode to provide whole or blockchain type query services?
Yeah, we don't want to compete with miners. So we want to work kind of in cooperation with SPV. So that, like, sort of the beginnings of that are the miner API services. So like with TXT, for example, has a flexible miner API. So it's kind of like you get to choose your miner. So we basically want to our goal is to facilitate basically the way that miners engage. Like, for example, for SPV services, we want to help facilitate the process of how miners actually engage with applications in whichever way we can. And so the beginning of that would be, you saw the starting with Minercraft, and then now moving to like how TXT kind of automatically crawls that miner API to check if those transactions exist. Services like that, that's kind of where we see our place in the future.
Yeah. I think it's important to note that there's probably a role for multi-layers of data indexes. Miners, of course, have the entire blockchain because they have to in order to do their job. And so that's a natural place to do sort of some level of distribution or selective distribution to different clients. That's not to say that other parties who aren't specifically involved in mining can't play a role in that filtering and distribution. And in fact, I'd say a lot of the Planaria services kind of fit into that space right now because they're essentially query services. And what good is a query if you're not confident that you're not missing results? But it will be fascinating to see how that does evolve as we scale up, and Planaria has to consider the economics of at least having a look at all data, even if it doesn't keep it all.
Just like a note on that, right now with Bitbus, you can basically, you can go back to around like block like 560,000. It could be in the future where part of the reason, if you think of like even the name Bitbus, is that it sort of is like it should be really looked at as like a synchronization engine where maybe there's an interval. We don't know how it'll look in the future, but it could be where you sync with Bitbus, just like BitSocket has a 24-hour interval of what we keep inside of the BitSocket DB. It could be that with Bitbus, that at scale that interval could shrink, and it could be up to the applications to probably will be up to the applications to store what's relevant to them. But we want to at least make sure to keep providing. We think like providing an index layer is really important at the moment.
I think for anybody that's relatively new to the Bitcoin SV space, trying to understand the data model, studying the different products in the Planaria suite is actually a valuable exercise, because you'll notice things like, for example, sorry, it's not Bitbus, the second one that you mentioned. Only keeps 24 hours worth of data.
BitSocket, yeah.
BitSocket only keeps 24 hours worth of data, and at first that seems like a limitation. Well, why not just have a product that offers all of the data as opposed to another product that, or having to use a different one for a different thing. But if you stop and think about the reasoning why those individual services have those kind of individual restrictions, it's because they're intended to be used in certain ways where those restrictions don't matter. By getting your head across those sort of different usage scenarios, it really helps to understand the different ways that people can make use of Bitcoin SV. So Anonymous asks, how does TXT relate to TXQ? What are the differences and similarities?
Yeah, I'll say they're pretty similar. I think you should look into it. Just look into the documentation, and I think you'll be able to answer that for yourself, I think. So yeah, that's all I'm going to say on that.
Okay. Konstantinos asks, okay, it's a question. Today's databases like Postgres, do they become 100% unnecessary with something like TXT?
I'm not. I don't. I mean, there's so TXT uses SQLite, and we did this purposefully because the peer-to-peer is all about portability, really. So I mean, if you want to create payment channels, you need to be able to share, easily send and share these channels, and so that's an example of why we thought that SQLite was the way to go. And but that being said, things like Postgres SQL, you may have there's different reasons why you'd want to use different types of databases depending on your application. So I wouldn't necessarily say that, but I think as for the P2P ecosystem, right now we thought that SQLite was the right decision. So.
Okay. We've got a question here about Powping, which has arrived fairly recently and seems to be attracting quite a lot of attention. And I think they're talking about the decision to hold transactions off-chain. Will you post Merkle routes of all of the offline Powping transactions to the blockchain?
So what I'll say is in the next week or so, coming weeks, we will be sharing more about what the future of Powping will be, and this is really an experimental approach for us, and we really want to test what peer-to-peer can mean and does mean, and so specifications about the protocol will be, I don't want to talk more about it until we're ready to kind of formally announce it.
Okay, we won't try to nail you down too soon. Well, while you're here, actually, a question I've seen pop up on Powping a few times is what is the correct verb? On Twitter, it is to tweet. On Powping, it is to something. So I think we might as well ask an authoritative source while we're here, while we've got you.
Yeah, well, I mean, you tell me, Steve. What do you think? What should it be?
I'm guessing Palp, but that's kind of awkward to say. So.
Yeah, I mean, I'll go with well, I mean, I think we'll let the users decide.
Okay. Last question here from John Pitts. Can TXT or anything in Planaria toolset mimic the advantages of a relational database? SQLite is actually a pretty rich database and a basis for most iOS apps. So TXT plus Oracle. Not quite sure what that last part means, but
yeah, I don't. Yeah, I think. I mean, SQLite is. I don't really quite understand the question. I'll say I think the advantages of relational SQLite really is a relational database. So I mean, I'm not really sure where he's going with that, but I guess as a final, you mentioned something earlier, like when you were talking about a BitSocket, and I think like one of the points that I think I wanted to be clear about is like our goal is really to give developers as many choices as possible. So you may like while it seems like peer-to-peer is somewhat conflicting with our whole ideology, like up until the point of TXT, everything we built was based off of deriving from Bitcoin itself. But we want the developers of the future applications to decide the infrastructure of the future, and so whichever way that goes, we want to make sure to provide them with the best tools. And so yeah, really our goal here is just to give you guys who are building good options, and everything that we presented today. I know I didn't have a lot of time to explain it or give kind of a detailed explanations, but I will say inside of the presentation there are links to each one where you can find documentation, and most of the documentation is pretty thorough. And if you have questions after that, like I said, I will be on Slack, and I'm happy to answer questions. And yeah, so I just wanted to get that out there, and that we are really looking to you guys to grow this space, and yeah, we want to assist you the best way possible.
So maybe when devs have figured out features that they want and need, they can palp it to you, and
yeah,
then unwrite it, and you guys and the team can deliver. Okay, well, we'll have to wrap this one up. In a few minutes' time, we have our final event from the day, which is a panel discussion led by Brendan Lee with a few of the old school app developers in the space and one of the newer ones. So we'll see you in a few moments.
Awesome. Well, thank you, Steve.
So building applications on Bitcoin is not just about building the application itself from scratch. It's about building on top of what already exists. And to lead a panel discussion today with a few well-known Bitcoin faces, we have Brendan Lee. Thank you, Brendan.
Thank you very much, Steve. So today we have with us Shashank Singhal from Coda, James Belding from Tokenized, and Ryan X. Charles from MoneyButton. Now, these are three quite different platforms that are available for people to use on Bitcoin SV. And so really to get started, I'd like to ask each of you what it is that your platform does and what problems you solve for developers in basically about a minute. So if we could start with Ryan, please.
Sure. Okay. So I'm founder of MoneyButton. And so what MoneyButton is we describe it as a simple payment system. So the idea is to make it extremely easy to integrate Bitcoin payments into web applications. So we let you do things like accept payments very easily. So you can accept payments to your business if you're a merchant. But MoneyButton has a lot more advanced features too. So you can do things like make it so that your users can pay each other. You can make it so that people can make, pay multiple different people at the same time. We have an integrated OAuth system, so you can have things like the user can log in and keep track of what they've purchased. We have a number of sort of advanced uses of cryptography inside MoneyButton as well. So you can even do things like encrypt your data and create digital signatures inside of Bitcoin transactions. So it enables a wide suite of different types of applications. So we would encourage people to look at MoneyButton. Basically, if you're making some type of web app that uses Bitcoin, MoneyButton may solve your problem and allow you to create things like social media, finance, and all sorts of applications on Bitcoin.
Thank you, Ryan. So jumping out of James, could you give us a 1-minute rundown on Tokenized?
Sure. Thanks, Brendan. So I'm the CEO of Tokenized, and what we're doing basically is focusing on taking commercial records, which the biggest part of that and the most important part of that is contracts and smart contracts, and really codifying them and standardizing them such that software can really automate a lot of the processes associated with the contracts lifecycle. Now, the heart of that and the most important use case we think is really in financial instruments. So today, most people are familiar with public securities, stocks, what have you. They got a ticker symbol, they're traded digitally, they're dematerialized. So we see there are significant improvements in that market, but we don't see that as the really compelling value proposition and the real revolution that's coming. And we really see the revolution in the alternative markets and the private markets, where you've got financial instruments that are essentially today just represented by a contract, a paper contract or a contract that's in a PDF somewhere, and software cannot make sense of it. And often the terms and conditions are fairly similar between these different instruments, but they're not codified. So the language that defines the rights of those terms and agreements and what have you are very, very different, but only different in wording. They're not different in spirit or meaning. So these types of elements can really benefit from being codified, and then have software use that to basically simplify the process, automate the process, allow people to actually understand what's going on better. And this is really, really important for developers, because our framework makes it much, much easier to interact with these, and then let your wallets and other software that supports and interacts with it, you have something to work from that's standardized.
Great, thank you. And so jumping over now to Shashank, could you give us a 1-minute rundown on Coda?
Yeah, sure. So hi, everyone. I'm one of the co-founders of Coda. So Coda is an API marketplace. So it's essentially a marketplace where people can buy and sell different sorts of APIs. And the difference is that it charges API consumers per call to use these APIs. So since the call of an API usually only provides a small amount of value, Coda uses subcent microtransactions to allow for these per call exchanges. And modern APIs are usually offered for free because there's no good way for developers to extract value from their APIs outside of monthly subscription plans. And Coda fixes this by allowing API consumers to pay for exactly what they use and no more, and allowing API developers to monetize code where this has traditionally been difficult and ineffective.
That's great, thanks. And sticking with Shashank and Coda for now, I was wondering if you could tell us, before you came to the hackathon in Seoul, did you have any experience with blockchain technologies? And if so, can you give us a bit of background and let us know what your decision or how you came to the decision to support Bitcoin SV and why you think it is the best choice for Coda and your users?
Yeah, of course. So my co-founder and we've been interested in blockchain technologies since around 2016. During that time, we fiddled with several different chains. And I believe my co-founder Andrew even built a small project on Ethereum, but not one that he continued onwards. But we didn't build anything significant on the blockchain until the first BSV hackathon, which was earlier on last year. And we always believed in scaling for big blocks as a path forward. So it was first BCH and now BSV that we followed in a blockchain sense. So when the chain split happened, we had a few factors outside of obviously big blocks that we were looking at when we were support. One was being a dedication to a stable protocol, which BSV keeps touting and which we, as application developers, we deeply respect. And also, a lot of the names in the industry that we support and believe in the most went with BSV. So we saw it as a clear choice because of that. And I think if today you look at the two ecosystems, I think it's quite clear that we did make the right choice. Now, yeah, when you look at why BSV suits Coda specifically, it's the massive scaling through big blocks. Coda's user base scales up, our on-chain transactions will scale exponentially. So we need a blockchain that can handle a large volume of transactions. And we've seen with various applications like Weather SV and Preve and a few others that BSV can really handle big time user transactions on chain. Low fees on BSV allow for microtransactions, which is obviously essential to our service offering. And as I mentioned earlier, a dedication to a stable protocol means we can be relatively certain that we won't encounter any big changes or struggles in the future.
Yeah, that's great. And I think a lot of what you said there is probably echoed by, the rest of the people on this call. Yeah. Okay. So jumping over to tokenized, James, I was wondering if you could, how would you best describe what it is that tokenized is solving for developers, and in what areas can they really leverage it to accelerate their projects?
Sure. So I think the concept of smart contracts has barely been touched in terms of where it needs to go to become a mainstream compelling product. There's much more to it than just code. And that's where Tokenize, I think our protocol really goes a long way. And we've made a lot of progress to taking it mainstream, in that we're starting to think about this in terms of what are the legalities of it? How does it interact with mainstream corporate customers who have real risks to manage on both the technical level as well as a legal level? There's jurisdictional risks. How do these things interface, right? And a lot of tokens and contracts today, it's a very different market and different set of rules and different experience for investors across different jurisdictions. So what we're really trying to do is we take script. So our protocol builds upon script. So everything you can do in script, you can do in tokenized protocol, but then it builds upon it and gives it a framework that, again, as it codifies, standardizes the important parts that make it actually legal, that make it meaningful, that take it into a realm that mainstream users can actually digest and actually operate with. And another way to think about this too is when we really started thinking about the problem in the beginning days or the early days, the expressiveness of a smart contract system is important, but it really, really makes the interoperability very, very difficult when you start to get into edge cases and unique smart contracts and various different scripts. If you think about it from a wallet perspective, being able to interoperate, not only understand every type of smart contract script and what that really means in a legal sense as well as a technical sense, but then also being able to build a user interface around it and a way for the users to actually understand what they're doing is a very, very, very complicated process. And if you do that in a market where everyone's doing their own little thing and they're having different variations of how script is actually going to be implemented, they're going to run into a lot of problems, and it's going to need to be standardized. So we are just leading that way. We're basically trying to build a really, really simple, as simple as it can be, but expressive so that it really does make smart contracts a consistent interoperable protocol that everyone can use, and it can handle all types of contracts. So that's really what we think the value of our protocol is going to be to developers and obviously any business that uses it as well.
Great. I think that's something that's really needed, actually. Okay, jumping across to Ryan, I was wondering, can you give the developers listening some, you did go into it a little bit in your intro, but a bit more of an idea of some of the ways that MoneyButton can be used. And if you have any to hand, can you share maybe some of the usage statistics that you have around what's currently happening with MoneyButton out there at the moment?
Sure. So let me cover, first of all, some more advanced things that you can do with it and some of the applications that are using MoneyButton. So one of my favorite applications is something called Baymail, B-A-E-M-A-I-L. Baymail is a peer-to-peer messaging application that uses MoneyButton to basically allow users to send an on-chain encrypted message to another user. And so they were one of the first applications that used some of our advanced features around encryption and OAuth and everything like this. So let me sort of briefly explain how all this works and what this is so that people get a feel for what you can do with MoneyButton. So first of all, there was the idea that we want to be able to do something like send a peer-to-peer encrypted message to someone such that only the recipient of the message can actually read the message. So we want to encrypt data. We can also do all sorts of interesting things. We put it on chain. So by putting encrypted data inside of a transaction, you can have an immutable audit log of things that happen, which can be something that you want in messaging. So you can have two different properties that are pretty complementary. It can be both private, but also sort of provably have like a provable record of what actually happened at the same time. So you get that by putting encrypted data on chain. So MoneyButton has something we call the Crypto Operations API. Not only can you use MoneyButton to make a payment, but you can use MoneyButton, you can use the same keys that are being used to make a payment to do other sorts of cryptographic operations, including encrypt a piece of data, such as a message to someone, and then sign that piece of data, put that inside of a transaction and broadcast the transaction. So that's what Baymail does to create a peer-to-peer messaging application using MoneyButton. So that's very novel. So of course we called it MoneyButton. The idea is that to make it really easy to accept payments, but also do lots of other interesting advanced things like that. So Baymail is one of the more sort of advanced applications using MoneyButton. And there are lots of other applications if you think about it that you can build with this. And similar to Bitcoin itself, we're trying to build the tools that allow people to build whatever they want, and you can concentrate on your application. And we're trying to solve the wallet problem for people so that you can rely on the wallet to do what it needs to do, and you can focus on your application to make your application as good as possible. So around the statistics of MoneyButton, we've had more than 1 million button swipes, and we have something like approximately 150 active applications using MoneyButton. So yeah, that gives you kind of a feel for it. I think that we are growing as far as whether, I think what's going on right now in terms of the usage is we're still very niche. So I don't think that we've reached a mainstream audience yet. So this is something that I've communicated about the status of MoneyButton, but I think the entire ecosystem, I think we still have a ways to go to reach a genuinely mainstream audience. And so that's why we spend a lot of time worrying about user experience, because we want to make sure that ordinary end users can use this stuff. So that's sort of where our general direction right now.
Yeah, that's great. And I've got to say, I've been using PowerPing a little bit over the last few days, and the experience there with MoneyButton and tipping and all of that is it's I find it very smooth and really a great way to use MoneyButton, especially with holding all of that data in the payment channels off the ledger and allowing people then to choose whether or not they want to put that information into the blockchain. So I just wanted to ask, of all of the things that you've seen deployed on MoneyButton, which really has been, in your opinion, the most unique use case?
The most unique use case. Okay, so I would come back to Baymail again. I guess I'm sort of hyping up his project, but I like that one just because it was so advanced. So a lot of the applications were much simpler and didn't necessarily use all of these features that we created. So it's cool when someone understands the power that we're trying to give to the developer, and they make a really advanced application, because there's a lot that you can do with this that has still not been explored. And we want to, over time, flesh out the full API to make it so that you can do everything. You can't currently do everything that you would want with Bitcoin, but that's exactly the direction we're going in. So I think Baymail, again, I would have to say is the other one, but I can give some shout outs to some of the other applications. So you mentioned PowPing. That one is an excellent, innovative application. There's Twetch is a big one. There's City on Chain. Most of the applications are social, so they tend to use a combination of like basically let the user log in and then do something with the other user, like communicate messaging and things like this. That seems to be the biggest use case. It's basically social media, but there are other use cases too. Like there is a trading application, TrueDex. There's a long list of like very innovative applications. So anyway, I'll leave it there. But to answer the question, I like Baymail because it was an advanced application that used many of the advanced features that we created for something like that.
Yeah, shout out to Darren. He's really one of the top devs out there, I think. He's done some stuff for me and it's been fantastic. So jumping back to you, James, and tokenized, I want to ask particularly about its use cases and whether you could give the audience some idea of the range of different applications that tokenized can be applied to, and the quickest and best way for them to get into it and to start leveraging its capabilities.
Sure. So I like to think of a token as simply an ownership certificate. If that's, you boil it down to its essence, that's what it is. That's why it's useful in the context of smart contracts and what tokenized protocol offers. So anything that has an issuer that was going to issue something of value that gives rights or obligations to another party or many parties, a token can be represented in the tokenized protocol effectively. It is that versatile and it is that foundational. And even when you get to things like coupons or loyalty points or membership to a gym, these types of you could tokenize those very easily because they're effectively ownership certificates. They're commercially meaningful, but a lot of people starting to forget that they also still have terms and conditions, right? Even a basic gym membership is going to have at least a page and it's going to tell you what those rights and obligations are all about and what you can, how long it's going to last, expiry, all those types of things. So again, the framework that we provided makes that the really common themes and elements that are important to any kind of contract like that codified and standardized so that you can navigate them very easily. And what it does is it allows any kind of ownership certificate to be, not only have the benefits of being on blockchain in the sense that it's immutable, it's interoperable, it doesn't have political risk, it doesn't have jurisdictional risk, but it has all this other stuff that's never been seen before in contracts. It makes it a lot easier. So you could really, is anything you can think of that is an ownership certificate of some sort that gives the rights to a user of something, it can be done on a tokenized protocol and it can be done fairly simply. The protocol is fairly extensible and there's a lot to it, but from a wallet perspective and from a use case perspective, you can narrow the features that you need to touch and the specification part that you need to actually interoperate with on your wallet to make it actually quite simple when you really boil down what you need to do on it. So from our perspective, yeah, any kind of asset idea you have, any ownership certificate idea you have, we are open to it. We've got a whole massive list in the background that we haven't shared publicly that we're working on. But we're also basically, if someone's got an idea, they can come to us and post in our forum, come on Telegram, and we will work with them to define a structure, a set of fields that is flexible and allows for other use cases to kind of work off that same structure.
Great, thank you. A question now for Coda. So based on my understanding of Coda, you actually end up having two sets of users. You have the API writers and then the API callers. Can you describe for us the interplay between these two sets of users and how Coda really facilitates this experience?
Yeah, for sure. So yeah, as you mentioned, Coda operates as a marketplace, so it does involve those two sides. We usually call them API developers and API consumers. And on Coda, API developers basically post and price their APIs, so they can put up any API that they own, and they can choose a price per call that API consumers would have to pay to use the API. Then API consumers can browse this marketplace for APIs that interest them. And then they can click into it and see information on how to call the API, what the API achieves for them, and detailed instructions on how to call and utilize the API to the best of your ability. And then after that they can call these APIs and benefit in real time. So Coda facilitates this by providing, one, the marketplace, which allows API developers to advertise APIs and API consumers to browse through these APIs and choose the ones that they like, as well as understand what the APIs can do. Coda also provides the gateway that sits between the API and the API consumer. So what this means is that the gateway, that the API consumer is only ever calling Coda's gateway. They're never calling an API developer's API directly. So this gateway authenticates users on Coda and also builds them in real time as the call is going through to the API. So on top of that, the gateway also collects logs and data on top of API calls, and that data is then displayed back to API developers, so they have a better understanding on how their API is doing and what they can change and what they can improve.
Okay, that's great. And can you give us a bit of direction on what the best way is for somebody to start using Coda? I think you guys have opened up a bit of a private beta, but can you give us any sort of timeline around a wider release?
Yeah, for sure. So as you mentioned, we're in a closed beta right now, but you can still sign up to the waitlist, and we usually roll out a release roughly on a weekly basis. So if you sign up to the waitlist, you will over the next few weeks get access just through that. But when it comes to a wider release, we're thinking maybe 2 to 3 months in the future, once we get a good amount of testing done and we understand more what we need to improve to get the product out to our wider audience.
Okay, great. So jumping back to Ryan, so I think many of the people are familiar with the simplicity of MoneyButton and how easy it is to deploy them in the websites. And I think it's possibly, you could call it the simplest payment system on the internet today pretty easily, I think. But could you give us, outline for us a bit more the advanced features that are offered and what they can be used for? You did touch on it a bit earlier, but I know there's more there, so.
Sure. Let me give you an example of one of the advanced features that goes beyond what you might think MoneyButton is capable of doing. So the name MoneyButton is designed to be really simple and to capture the essence of it, but it is more advanced than simply a button. So we created something called Invisible MoneyButton, which allows you to basically fully customize the user experience. So it's more than literally just a button. So what you can do is you can have the users basically log into your application, and they will grant you permission to spend automatically on their behalf. So this lets you do all sorts of interesting things. I mean, you can have video games where the user clicks around with any type of interface on the web. You can do things like automatically broadcast payments. So if you want to automatically write data to the blockchain, I mean, that is in effect a payment. You're paying the miners. So you can automatically write stuff like that. So you can have applications like a social media application or a game where the user's actions are being written to the blockchain. So you can really fulfill that using MoneyButton. So that requires, this uses our new Invisible MoneyButton API. It built inside of Invisible MoneyButton are all of the other features you can do with MoneyButton. So those are things like sending to multiple outputs, writing scripts inside the output. So you can do many advanced scripts. You can send to Paymail, so you can take advantage of all the features with Paymail. So you can bring in other wallets. So if other wallets conform to the Paymail standard, you can interact with those wallets as well. You can do things like track what the user does. So in terms of what they've purchased and things like this, using the integrated OAuth and signature abilities. You can even do things like single sign-in. So part of the philosophy of MoneyButton is to make it so that not only do we have good user experience button, but actually better user experience than what users are used to anyway. So the ability to sign into a website by just swiping MoneyButton once, for example. And that would be something where a user would actually create, they don't know what's going on, but they create a cryptographic signature to literally sign into a website. So that gives you an idea. So there are many advanced things you can do with it, and people should check out Invisible MoneyButton to know how to create advanced user experiences using the MoneyButton wallet.
Yeah, some of the ways it's being used are pretty amazing, and I just wanted to ask a little bit more. So, I mean, it's quite a different experience from how the typical web login works. You know, most people would be familiar with putting in a username and a password and then logging in. But with Money Button, it's very different. You simply swipe the button and you're logged in. Can you give us an idea of how this can keep user information secure, and especially considering the fact that the button acts as a completely in-browser wallet and is custodial in a way?
Yeah. So, well, so we are, from a business perspective, we are not custodial. The wallet itself is non-custodial. And what that means is the keys actually live on the end user's device. So our company does not hold the user. The keys are actually encrypted with a hash of their password that our company never sees. So what that allows us to do is the encrypted wallet is backed up to our servers. So anytime you log into a new device, it retrieves the encrypted wallet and decrypts it with your password. So the advantage of this approach is basically that our company isn't a honeypot of money or something like that. We don't hold the money. The money is held by the users. And those same keys, it's not just money. Those same keys are what you use to sign into it. So when you literally swipe Money Button, you're signing in, you're creating a digital signature to log into a website. That's literally what's happening is the keys are living on your end user device, and there is a digital signature that's being created when you swipe Money Button. So the way we keep it secure is just like that. I mean, this is, you know, in our opinion, delivering on the vision for Bitcoin, which is that if the end user has the keys, you get all these benefits. You get, amongst other things, you get the security benefits of there is no giant like central point of failure having all of the money or all of the other data or anything like this. The end user data is fully controlled by the end user. So everything, and then what the developer can do though is like you can still do it however you want to inside your application, but the idea behind the paradigm is that the user should own it. So they can use these technologies to encrypt the other data that the user has. So so long as people build that style of application, you can still make things centralized if you want to when you build an application. But we allow you to build applications that are completely, you know, allow the user to properly and fully own their data. And that is why it's more secure. The data isn't in some central location somewhere.
Great. That's awesome. Thank you. So jumping back to James for tokenized, and you know, with much of the world moving to remote or paperless solutions, can you give people a bit of a window into some of the ways that tokenized identities can be used to improve security and safety of user accounts and information?
Sure. So identities it's a really complicated topic, really, I think. So I think it's important to kind of lay down the foundation here. So I think identity, I don't think we're gonna have a single source of truth for identity ever. Like you're a physical person, and the records that support who you are come from various sources and can be attested to from a variety of ways, right? A lot of electronic methods coming. So today we've seen a rise in eKYC, which is like what you see with the neobanks and a lot of just modern banks and stuff in general, Coinbase, all those types of exchanges, where they basically take passports, physical papers, documents, proof of residence, and they take a scan of it. They do some algorithms, AI on it, and determine the legitimacy of it. And they kind of validate that you are who you say you are, and they tie that to some public keys that you provided them or they provided you to operate and do business with them. And they've essentially got a database that connects that to it. So we think that there's a bunch of things that can be improved with not only tokenized protocol, but just the blockchain itself and how this can all play out in this new, more remote, more digital world. And a lot of it comes down to sort of what Ryan was saying too, is the non-custodial component to this, right? You've got the users being able to manage their own keys, and those keys being distributed across millions of clients or billions of clients around the world. So there's no centralized honeypot, but you still need to have the likes of passports, driver's licenses, other types of certificates is really what they are, issued by authorities who do some kind of process. So you can take a token that represents an identity like that, like it's not really an identity, but it's a certificate that goes towards building identity, and you can issue it to a user's public key so they can control it, but you still have an authority that controls that to some degree as well. So they can revoke it, they can confiscate it, they can set the terms and conditions around that, how that's managed. So that's a really important component of it. The other component to the identities, which I think is a powerful thing, and it's a slight tangent, but I think still relevant, is identity oracles. So this is something that we've conceived and built into the protocol. And what it is essentially specialist companies out there that act as eKYC verifiers. So they take those documents and what have you, and they basically manage and ensure that the people who say they are, with respect to public keys, are linked to a identity that's been verified through all those documents. So with that is some interesting things come about. So with smart contracts, you can then set terms and conditions that are enforced by smart contracts through software, dependent on identifying characteristics that are part of data. So like the age of a person, the location, their status, whether they're an accredited investor, whether they're not, and anything else you can really do. So you can then therefore have a tokenized level where you're dealing with contracts, where you're dealing with the ownership rights of things. You can have terms and conditions that are built and centered around identities, with these identity oracles actually providing attestation of certificates to go along with it. So there's a few different angles there that I think are really, really important. And another important part is how blockchain is really going to play a role in the security component. So along the line of there being no honeypot, I think that's really, really important, where you think about ransomware today and companies that have databases that are privately owned by themselves coming in and corrupting that data, or if you have a certificate authority, that all that data can be called into question, so to speak. But when you have a blockchain and immutable ledger that records all that and timestamps that, you can actually know for certain where the certificates are valid and where they're not. And again, that all lends to a more secure, more robust system where identities can be used to affect their will in commercial matters, in terms of personal matters, health matters, and ultimately, I think just a more robust, better, more resistant kind of system overall.
Awesome. Jumping now to Coda, and last couple of questions here. So I wanted to ask, most API marketplaces, they've got fairly convoluted subscription plans, and I think this is mostly due to the overhead that comes with processing online payments. Can you give people an idea of just what's possible in terms of API call pricing with Coda, and how you guys are going to price your delivery of the service?
Yeah, sure. So yeah, you're definitely right that that mostly APIs currently revolve around monthly subscriptions, and that is largely because processing online payments is so difficult and so expensive to begin with. So pricing in Coda is based on microtransactions. So calls between from API consumers to API developers can be as little as half a cent currently on the platform. So it's sub-cent, and that will continue to decrease as we further optimize the platform. At the moment, when it comes to pricing our own part of the offering, at the moment, as part of the closed beta, we're not actually pricing, and we're letting our early testers use the platform for free. Moving forward, we'll be taking a small percentage fee off the top of each API call. So as they go through to the end user, we'll be making a multi-output transaction. So to take a small piece of the fee off of it as each transaction goes through. I don't hear you, Brendan. I'm not sure if that's just me.
Oh, sorry. Yep, that's my mute button didn't quite turn me back on again. So my last question for today, and I just want to see, so it's easy to see why Money Button is Money Button and why Tokenized is Tokenized, but Shashank, why is Coda Coda? Is there any behind the name?
Yeah. So every time I'm asked this question, I always wish I had some exciting story about how it relates to me and society as a whole. Unfortunately, it's not that exciting. So as you know, Coda was born during a hackathon. So when we were building it out during a hackathon, you don't have hours to contemplate the perfect name because you don't have hours. So we were looking through what we were doing is we were looking through available.com names that were relatively short and simple. And we had a few candidates. We were like, oh, this is great. Then we saw Coda. And since we're Australian, it's C-O-D-U-G-H. It's pronounced the same for us, Coda, as C-O-D-E-R, Coda, right? So we're like, oh, this is great. It's applicable. It relates. What we didn't account for is that the rest of the world doesn't pronounce it like that. So everyone gets really confused, and that's a problem. But yeah, no, as my co-founder says, it's just quirky enough that we still enjoy it. So I
love the name. It's great.
Yeah, I really like it. I think it's got zip. Okay, that's it from me. I know that Steve Shatters had a few more questions that he wanted to ask in the last 10 minutes or so that we have today. So, Steve, if you want to join us.
Hi, everybody. So I've got some questions from the audience, actually, and we've got exactly 10 questions and exactly 10 minutes. So I'll ask you to try and keep the answers to about a minute, if I've got my math correct. So Marco asks, he's got a question for Ryan. Do you expect to have tokenized-based tokens within the Money Button wallet to use as payments?
Yeah, great question. So the vision for Money Button has always been to ultimately have fiat currency tokens inside Money Button. So tokenized will allow us to do this. So somebody will have to create like a actual fiat currency backed token for that to ultimately work. But we certainly want to integrate token technology inside Money Button itself for that reason, as well as countless other reasons. So all the usual applications for Money Button. The way we see this is Money Button should be basically where the user's keys are. And so we want to provide the functionality necessary in order to enable every type of application that requires usage of those keys. So tokens are a giant portion of this. And I think that what will probably happen is it'll be the primary use case ultimately. With respect to timing and things like, I don't want to say anything about like a timeline for going to have tokens in Money Button, but that is definitely a part of the vision for Money Button.
Okay. So the next question, I think, is quite topical. It comes from Stein, I think from Norway, if it's the Stein I'm thinking of. It is for you, James. Is Tokenize working on e-money?
Hey, Stein. Yes, we are very hard. That's the main first phase for us. So we're going after licenses to allow that to happen. We've developed a white paper that we submitted to the Bank of England that gives them a full framework with every concern that they have, every possible question answered, and a solution for it all. So behind the scenes, we're doing a lot of work that we haven't shared publicly, but we're going, like, that is the main focus right now, is laying down that foundation for proper e-money, eventually going to be issued by central banks. And we have a plan how to get there as well. So we have a private market solution that will eventuate into what we hope to be actual central banks issuing and controlling the smart contract. We've also developed a system to allow for identities to be like, so basically AML and KYC compliance to be enforced to comply with the laws that they need to have for these e-money to be actually be e-money, but also to do it in a way that open source wallets can still interact with these e-money without having to be a regulated entity or even have a license. So there's a lot of components to this, but we've really thought carefully about all this, and we're just driving hard towards getting it done. We'll see how long it takes. Like, we've got some obviously timelines in our head and things that we're working to, but there's a lot of uncertainty when it comes to the regulatory side of things and getting mainstream corporate customers comfortable with all of it.
Okay. And we've got a question for Shashank here for Coda. So it says calls to APIs can probably have very low values. Are you going to use pay per M calls or payment channels or some other mechanism? I think they're referring to, you know, API call that might be 1,000th or 1,000 calls per cent or something like that, where the cost of the call is actually lower than a transaction fee.
Yeah, definitely. Payment channels are definitely on the roadmap, and that's part of the optimization of our platform. So when it comes to, like, one good example is, sure, like you mentioned, when there's 1,000 calls per cent. But even if you're making 1,000 calls in a small period of time at all to an API, no matter how much that adds up to, payment channels are still valuable because that still saves you a lot in network fees sending through a single transaction rather than many. So when it comes to APIs, specifically APIs that are called a lot in a relatively short period of time, or that we can assure that will be consistently called by users, payment channels will definitely be implemented to optimize that fee.
Okay, so we're going to jump back to Ryan. I had thought this might have been a tongue-in-cheek question, but I actually think it is a serious one. So it says, UX question: if it's a button, why can't I press it? And I think they're getting at the decision to go swipe versus press. Was that a UX thing, or?
Yeah. Okay, good question. So, you know, Money Button is somewhat famously not something that you press, it is something that you swipe. So we started with the name, but we wanted to make the best user experience for pressing the button. we realized that swiping was actually a better user experience in the general case. The reason for that is you want to basically visit a new application and not accidentally send money. So if it were simply something that you pressed, we wanted to make it where the user is much more deliberate about what they're doing while still making it very easy to use. So a swiping action ended up being that, because it's very hard to accidentally swipe money button. You would only do it if you intend to actually send a payment. So it really is a user experience thing first and foremost, and that's why it's a swipe.
Okay. I've been curious about that one myself. The swipe for free button, though, I wonder if that might have an alternative user experience at some point in the future. But I'll leave that one for you. I won't make that a question. I've got 3 questions left here, but I'll start with the one that is probably one for everybody here. Which is, do you see a future where a key pair is issued at birth, which will be the root of a hierarchy tree for each person, or perhaps a set of them with additive biometrics? So perhaps this is a key that's actually biometrically derived that you carry through your whole lifetime.
Who are we starting with? Should I answer first?
Well, yeah, let's start with Ryan.
So, I mean, my opinion is both yes and no. I think that probably we will see increased usage of cryptography, and we'll see, yeah, you'll probably have keys issued at birth. However, let's not equate keys and identity. That doesn't mean your keys are you. It just means it's useful to issue keys right away. I'm not sure that they could be a part of a hierarchy, and what will probably happen is you could lose your keys and it's okay, because there are other keys involving multi-sig and threshold signatures and things like this, where your parents, your hospital of birth, your government of birth, and things like this can give you new keys if necessary. It would be something where we have a system similar to what we currently have with something like a birth certificate, but where we just add cryptography into it to make it a little bit more secure. But we're not gonna assign some permanent key pair at birth, because, well, you can lose your keys, you can be hacked. And so there's got to be a way to change them out, just like there currently is with birth certificates and passports and things like this. So that's how I personally see that playing out.
Mm-hmm. Shashank, do you have any thoughts on that?
Yeah, I agree with what Ryan said. And in general, my understanding of keys is, you never want to have a single set of keys that sort of controls everything. So when there's a key pair at birth, then your entire life you're reliant on this single key pair, and you could get hacked, you could lose it. It's sort of if there's a really high value, a billionaire you're going for, it's a single target that everyone will go for, and you need to be able to switch out those keys to an extent. But there can be a relationship there to biometrics, how it generates new keys over time depending on your biometrics, and you can regenerate those when you want in a different format, perhaps.
Sure. So, I mean, one common form of biometrics is fingerprints, and I've often said fingerprints are a password that you leave copies of all over the place. But that's not to say that they're not useful as part of a multi-factor authentication scheme, for example. They certainly can improve the user experience whilst adding a degree of security. James, what do you think?
So we are driving towards that vision. We believe that to be the case. However, is every person going to have one set of keys their entire life? No. People are going to lose them, like everyone else says, and there's going to be ways to deal with that. Insurance, business processes, like authorities having keys for you to get you out of the shit if you do lose your stuff. But I don't believe the biometric component is important to the generation of keys. I don't think that has to be part of the equation. But like Shatter said, I think biometric is really, really important to the multi-factor component when you're managing wallets and security. So.
We'll do one more question, but there's just a quick comment here. Someone's just said that the swipe is great and it's incredibly satisfying. So there you go. Your UX research was right about at least one customer, Ryan. So last question is for Coda, Shashank, and just quickly, have you built the whole platform from scratch, or do you rely on other services like Culinaria, etc., for some parts?
So we obviously, we built most of the platforms from scratch, but when it comes to services, we obviously use Money Button's brilliant BSV library for many of our functions. We use BitSV as well for our gateway. We use we obviously have to communicate with miners, so we communicate with what's on chain at the moment for some of it, and Tal for others. other bits and pieces of our services. So we need to use parts of the ecosystem here and there, but the platform itself has been built from scratch.
Okay. All right. Well, thank you, everybody. We'll have to wrap this up there, and it's time for a few closing comments for this first Bitcoin SV DevCon. Thanks to the Bitcoin Association. So, of course, as we come to a close, this is the first of these events that that I know of, certainly, that has been done in Bitcoin SV's lifetime. Of course, we really wanted to do this event in person. It was originally planned for San Francisco and then a repeat in Shanghai, but due to the current circumstances of the world, that is, of course, a little bit difficult. But we certainly intend to be doing that in the future. And goal for future events is to make them much more interactive with live hack sessions with your mentors walking around the room, able to help you as you work through the same problem that all the other devs in the room are working on, workshop sessions and much more. So you'll be hearing a lot more about future events if you just stay tuned to Bitcoin Association. What we've seen over the last couple of days is really just a small sample of some of the tools and applications that are available on Bitcoin SV for developers to use and to build on. There's plenty more. I'll rattle off a few. There's MatterCloud has an awesome API that just got released a few weeks ago. What's on Chain is a block explorer that also has its own API. BitcoinBlocks.live, if you actually want to see the network in action in real time, that's a very visually pleasing website, especially in the middle of a period of high activity. We've got multiple social media platforms. We mentioned Powping earlier. Of course, there's Twitch as well. And I think Memento, I'm not sure if they've launched yet, but yeah. The advertising space is being attacked by TonicPow. There's BitSV, which is both a gateway API and a Python library. There's a bit of a name clash there. And on the wallet side, you've heard from Handcash and MoneyButton. There's also MetaStream, which is very application developer focused, and RelayX, which is attached to the oh my god, I've just gone blank. The exchange, not OKX. No, it's gone. I apologize, Jack. Anyway, RelayX wallet. You can find out a lot more about all of these tools in various places. The Bitcoin.com website has some guides to aid you, and of course bsvdevs.com. And there's plenty more. Jump on one of the social media sites, social media applications, and ask a question. I'm sure you'll get plenty of answers. So as we wrap up here, I'd like to say thank you to the entire event team and Raylene, who has been busily keeping things ticking along in the background. To the We Are Developers team, of course, who have provided the platform and a lot of the technical assistance, and of course to Jimmy and the entire Bitcoin Association, and lastly to all of our presenters. Going forward, finding resources and enabling developers to become more capable of interacting with Bitcoin and building on Bitcoin SV is a primary goal of the Bitcoin Association. In fact, they run an entire developer program to basically facilitate the growth of developer capability. And I'll tell you about a few of the things that they do. Firstly, there's webinars. Over the last 2 months, the Bitcoin Association has embarked on digital education with a series of Bitcoin SV webinars. We've had a few expert scientists and engineers from nChain presenting on various topics that span the whole world of Bitcoin. And if you missed the first series of them, they will be repeated later this year. The script definition language that I showed yesterday, I've had a few people ask already. I actually only got through about a third of the stuff that I was going to demonstrate, so there will probably be an extended version of that coming at some point soon, and I'm sure Bitcoin Association will help facilitate that. Right now, the third Bitcoin SV hackathon is currently underway. There's actually still time if you've got an idea, or even if you haven't, you can go join and see if you can form a team with some people. The coding round of this hackathon lasts until August 18. So yeah, there's time to put together a winning entry, and the prize pool for that hackathon is actually a total of $100,000 in payable in Bitcoin SV, of course. So that's a tidy sum. And of course, there's the BSV Academy. We know that the growth of the Bitcoin SV ecosystem depends on more developers becoming skilled and interested in building useful applications for the Bitcoin blockchain. So one of the major priorities of Bitcoin Association for 2020 is to launch the BSV Academy, which is a comprehensive developer education and curriculum program that aims to deliver quality online courses. Initially, there will be in-person courses coming after that. So this curriculum will provide beginner, intermediate, and advanced courses in three sort of major streams. There's a Bitcoin theory stream, there's a Bitcoin infrastructure stream, and a Bitcoin development stream, obviously, all with their own kind of special focuses. So you've heard from a few members of that education team over the last couple of days. Brendan, who just hosted our panel, Josh Hensley, and Evan Freeman. And of course, Raylene, who's been keeping things ticking in the last couple of days, is the program manager for that. But they're on track to deliver the first of these online courses before the end of this year. So keep your eye out for that. And of course, there are the CoinGeek conferences. Anyone who hasn't been to one, ask anyone who has been to one, and I'm sure they'll tell you that they're a hell of a lot of fun. The last one was here in London right at the start of this year, just before things started going a bit awry in the world. So CoinGeek have actually announced that their next event will be held in New York this October. It's going to be a hybrid live and live stream experience. So some people will be able to attend in person, but of course, if you can't, we're going to make sure that the online experience is just as good. And so we'll be ensuring that global circumstances won't provide a barrier to attending. And you can find out more about all of these things at the bitcoinassociation.net website. So thank you everybody for joining us. I know that your time is precious, and I'm pleased that you've chosen to spend some of it with us. I really hope that you've managed to learn something useful over the course of the weekend. And of course, if you want to go back and watch any of the presentations in more detail, the whole pause and screenshot and zoom in to see what was on the screen at the time. The videos will all be online very soon. So one last thank you to everybody involved, and we will see you at the next BSV DevCon and probably at CoinGeek New York before then. Thank you.